All right, here we have James Douma with us, and he's been following Tesla's full self-driving and also autopilot features for many, many years. He's a Tesla investor, but also a long-time software expert, but also a neural net and computer artificial intelligence or machine learning expert as well. And so I joined with James Douma. I'm curious, like, when did your kind of first interest in Tesla specifically, their autopilot and their features start, and what did you do to get kind of up to speed and keep updated with their development?
So my interest in neural networks and artificial intelligence far predates my interest in Tesla. In fact, I bought my first Model S because I wanted to get some experience with Tesla's AP1, which I was thinking at the time was probably one of the first instances of a really consumer accessible neural network, that was trying to do a non-trivial thing out in the world. There there are more consumer-facing, bigger systems out there, which are mostly, language translation, for instance, or like Google's search interface does that sort of stuff. But as an individual who's like not connected to any of these companies, I can't get under the hood, and it's hard to get a sophisticated experience with Google's products, with some exceptions. I mean, I track to Google's language translation, for instance. So I speak English, I speak Japanese well enough that I can evaluate the quality of the search engine. And so for quite some time, or the search engine, the translation engine. So for quite some time, I was watching improvements along that, and I could use that as a metric for advancement in the functional utility of these technologies as they came out. But Tesla moving into trying to use neural networks to solve the driving problem, that's a whole nother level, right? In many ways, not only is it not a natural language, natural language, it has a lot of characteristics of its own. So basically, understanding the spoken word, translating languages, or understanding the meaning of sentences, these are all basically NLP problems, natural language processing problems, right? But there's this whole other space of utility that neural networks can do, which has to do with helping machines interact in the real world, to understand the real world, and to take action in the real world. And I think the first really big scale, meaningful application of this is going to come in self-driving cars. So I've been interested in this topic. I was actually, as an investor, I was looking for investment opportunities in this space, and mostly coming up pretty dry. And Tesla actually showed up on my radar as one of the first serious investment opportunities here, because it's a company where they're much more committed to betting on the curve of improvement of deep learning than the other players in the space are, right? Most of the other players in the space, basically all the other players in the space, predate the 2012 ImageNet results, which is when essentially deep learning really came into its own as a technique that people would choose over more widely used, more conventional techniques that had been around for a long time. But it has this characteristic that it's improving at a much more rapid clip than these alternate techniques are. And so if you believe, as I do, that improvement curve is going to continue for quite some time, what it means is that neural network-based deep learning techniques, they're going to overtake a lot of these more mature techniques from other fields, and they're going to end up being the way to solve a lot of these problems. So for instance, if you had bet on a conventional vision approach for solving the self-driving problem, and you had built up a lot of infrastructure in that space, and you're kind of committed to that approach, and then deep learning shows up. So a company that bets completely on deep learning, they're starting out behind. But if you believe, as I do, that deep learning is going to be a big lever and it's going to improve quite rapidly, the company riding that curve up is going to surpass the one that has more experience and get to a more effective product in the real world sooner. And when I looked at Tesla, I felt that was what they were doing, that they were making a bet on these techs, and in a really serious way. And that because that was something that I wanted to look for investments in and wanted to bet on, I became very interested in Tesla as an entity, which is I actually worked at an EV company for some years back in the 90s, right? So I had experience with EVs and developing technology for EVs, but I actually wasn't very interested in Tesla as an investment prior to autopilot coming on. Just because I'd had experience in that business and I knew what a tough business it was. Like, you can have great tech and like you can be doing everything right and at the implementation standpoint and still fail terribly in that space, because the characteristic of the market, the power of incumbency, the just the momentum that everything has. But deep learning and neural networks applied to problems, they're a much bigger lever than just a better motor or a better battery. Mm-hmm. So that was the point at which I looked at Tesla and I thought that this was something that had a good chance of being, essentially hitting it out of the park.
Yeah.
So I became very interested at that point. So I got my first Tesla. I put a lot of miles on it, trying to understand what the networks were doing. Then when they came out with AP2, I got another one, and I put a lot more miles on that. I think I've got 80,000 miles on AP1 and AP2 at this point, which, in fact, it's almost all the driving I've done in the last 5 years has been me getting in a car, turning on AP, and going on a road trip. Mm-hmm. So it's been fun to watch it advance, and it is, that experience has in no way diminished my enthusiasm for how the technology is progressing and Tesla's the opportunity that they're facing.
Mm-hmm. I'm curious, like I kind of want to focus kind of a lot of our conversation on what is going on with Tesla's full self-driving, and I want to help people, and also myself, try to figure out, okay, what's happening with Tesla's full self-driving, not just on the surface level, like what people might see on Twitter feeds or on YouTube and people trying out full self-driving beta, but I want to help, and I want to try to gain understanding on what's going on behind the scenes, or kind of in the, I want to say in the code, but what's happening that people aren't seeing, meaning where is this headed, and like what is Tesla's strategy, how different is it, right, compared to other companies? How much of a lead does Tesla have, right, with this? And also, what kind of, I guess, business model potential cases do you see in the future? Now, this is like probably like 10 or 15 questions all wrapped up into one.
Yeah,
which,
but let me make a comment on the behind the scenes sort of aspect of the thing. So, I've been able to get access to the code behind Tesla's neural networks and with some collaborators and look at this stuff. And because it's a specialty of mine, I did that because I was looking for insight into how their development effort was going and whatnot. I think that for most people, the best way to understand where Tesla is and how things are going is to get in the car and drive the product, right? Because at the end of the day, when I look at everything that I've learned from drilling down into the neural networks and looking at the structures and watching them evolve over time, I've been doing this long enough that I've seen, I saw the early efforts, I saw what they did later. I have a pretty good sense of like how they adapt and change and various kinds of things they've tried. But even all of that said, I feel like I understand the product a lot more from getting in the car and driving it, in different kinds of situations and paying attention to what it's doing than I do from looking at these flow charts and diagrams and network architectures and watching how they evolve over time. I mean, that's useful, but it's not nearly as useful as just driving the product, like getting out there and using it in the real world is. And that's something that anybody can do.
Yeah, I mean, I definitely agree. I mean, I've had autopilot for quite a while, and I've seen the improvements over time. But I think that the challenge, though, is with AP2 right now, it's like it's progressed and it's improved, but it's actually like sometimes, unless you're driving a lot, like it's sometimes hard to notice the subtle changes in some ways, especially let's say over the past year or so. And then with full self-driving beta that's come out, most people don't have access to that full self-driving beta, so they're not able to really gauge Tesla's progress. And it seems like Tesla has kind of like separated the development tracks, right? You have Navigator on autopilot, they're freeway driving. The team is probably maintaining it, slowly improving it, but it seems like the bulk of the effort for Tesla's, autonomous driving effort has been focused on this more full self-driving, right? Like city driving, stoplights, turning, parking lots, etc. And so it's hard for the average Tesla, let's say, owner to keep track of Tesla's full self-driving improvements because it seems like we haven't been able to, I guess, see the street driving, the local driving, in person. Like I haven't been able to. I have in a sense. Like back in Autonomy Day last year, I was able to take a ride in a full self-driving Tesla, where we had an engineer come and he was driving us around without any, hands, etc. But it's hard for me to keep track of that development because I don't have the beta version, right? So I mean, like that's part of the challenge is the beta version isn't out yet for most people. So it's like, how do we keep track? What can we learn about it? And what can we learn about where Tesla's headed, I guess, with this full self-driving beta? Like, that's kind of my interest right now, I think.
Yeah. So unlike earlier, there have been a number of step changes in the capability of AP over the last few years. There was when V9 came out. There's, when AP2 first shipped, and famously AP2 was behind AP1 for a long time after the hardware came up in it. And there have been, like when NOA came out, right? And there have been a couple of NOA features that were notable, extensions of the capability of NOA, like the cut-in detection, like kind of famously from a little over a year and a half ago, where you could see these step changes in the behavior of the thing. But the coverage, call it YouTube coverage, the coverage of the YouTube fan base that was going out and basically documenting this stuff and putting it out there so that people who didn't have the car could, get a sense of what was going on, wasn't nearly as good as it is right now with FSD beta. There are at least a half dozen like dedicated, users out there documenting what the vehicle is doing. So I don't have the beta in my car either, so I can't drive it. But I feel like unlike earlier versions, I could get a pretty good sense of at least where it's starting, right? Not the rate of advancement and the rate of improvement. So each time there was a step change before, you would get this thing where a new capability would get pushed out and it would be buggy and you'd have to pay close attention to it. A lot of times it would feel like a regression, like they'd pushed out this new capability and all of a sudden AP wasn't working as well as it had been just before you got the improvement. But then what you would see is like, the interventions, the failures, would go down. Your level of comfort would go up, and then it would gradually get smoother and smoother over time. And that curve would take, 3 months or 6 months to kind of fold out before like it was time to get another step change in capability or something like that. We're going to see the same thing with FSD, just realistically. The first, 3 or 6 months, what we're going to see is Tesla finding bugs, essentially really simple things that they missed, right? Or really simple cases that they didn't look closely at enough. They're a relatively quick fix, right? And then once they've mostly ironed out the bugs, then they work on refining things. So initially, your failures kind of fall into two big camps, right? One of them is a simple oversight, which is correctable in the logic or of the code. And another one is the perception system's accuracy is inadequate in some situation. Like, it's 90% or 95% accurate, but in order to actually provide the experience people want, it needs to be 99% or something like that. So in a lot of those cases, once you've dealt with the bugs, the next thing that you want to do is basically you turn on, Carpathy's data engine, and they look at where are we not getting what we want. Let's get some more of those examples. Let's put them in the training system. Let's, we skew the distribution of accuracies for the cases, and we bring the accuracy of the perception system to where it needs to be to provide the experience that people want. Now, that takes more time and it's more subtle. So you don't get these, there was that one situation that always failed before, and now it just doesn't fail anymore, right? And that's basically, most of the time, that's going to be fixing a bug. That's not going to be a change in the perception system. The changes in the perception system are more along the line of, I just feel more relaxed in the car. I don't feel like I have to pay as close attention to it because it's not getting too close to the truck, or it's not, jerking slightly as it takes the off ramp, or it's not, there are a lot of subtle things as a driver where you can where you can tell that the perception system is not quite sure about what it's supposed to do. So it hesitates, and what, as a driver, you get the sense that the vehicle is more confident in itself when when it's 99.9% certain of what it needs to do in 2 seconds, as opposed to when it's 90% certain of what it needs to do in 2 seconds.
Mhm. I'm wondering, how long do you think this beta, or I guess they could extend the beta, obviously, for quite a bit, but how long do you think it'll be before Tesla does more of a wide release where, everyone with full
Yeah.
self-driving option can
So
get that in their
that's a really
car?
interesting question, because my sense of the level of polish that the FSD beta has now is that it's already more polished than, say, NOA was when NOA came out, like quite a bit more polished. And that, I mean, so Tesla was talking about releasing this like a year ago, and they didn't, right? And I think, it was natural to assume that the reason they didn't was because it hadn't achieved a similar level of polish to where say NOA was when NOA got released. And that's kind of a cause for concern or pessimism or something, because it seems like that means the FSD problem is harder than they thought it was, and they're not able to meet that. But I look at the videos that are out there right now, and my sense is it's actually at a much higher level of polish than it was before. And when I sort of extrapolate back in time, it's not difficult for me to believe that a year ago, that if they'd been willing to release FSD with the same level of polish that, say, NOA had, they might have released it a year ago. They might have been at that stage already. And if they decided not to do that and wait until now to release it, it's less because their technical capabilities aren't proceeding the way they want, as that they're being more conservative about, they want to get to a higher level of functionality before they release it, which kind of makes sense for something that drives on city streets. It's a much more complicated problem, right? But it could also be that Tesla's just getting more conservative, that they don't feel like they have to push the envelope as much for whatever reason, or maybe they feel like it's not as rewarding or fruitful to push the envelope as hard as they did with
Sure.
NOA and earlier versions of
Yeah,
AT.
I would imagine, like, if there are like bad incidences of, city
Mm-hmm.
driving, hitting pedestrians or bicyclists, like that is going to be hugely negative for
Sure.
Tesla. I'm sure Tesla's keenly aware of the stakes at hand, for full self-driving.
Yeah, I mean, so I thought about, there are certainly, once you start interacting with pedestrians, the potential for really bad outcomes gets really high. On the flip side, if you want to think about how hard it is to handle a situation for one of these machine learning systems, right? So there's a certain amount of time you need to react in any given situation to avoid a bad outcome, right? And that period of time gets a lot shorter as the vehicle gets faster. But at the same time, as the vehicle is moving faster, so the perception system has to absorb all of this information and run it through a very sophisticated engine, right? It might have to correlate what it sees over multiple frames to develop a level of confidence to be able to take action and whatnot. That all takes time. That time also shrinks the faster you're moving, because the cameras don't run any faster, and the neural network doesn't speed up when you drive faster. So to a first approximation, the difficulty of avoiding a bad situation, it goes as roughly, it's somewhere between the square and the cube of the velocity, right?
Mm-hmm.
So if you're driving at 30 miles an hour versus driving at 60 miles an hour, the exact same system has a huge advantage. It's probably 10 times safer, all other things being equal, just because the level of confidence it can build up and the amount of reaction time it has is so much larger
Sure.
at
But on the
city
flip,
speeds.
But on the flip side, the complexity of the situation dramatically increases in these
It does,
local driving
right? So
scenarios versus,
it's
the
what I'm
freeway.
saying basically is it's a complicated trade-off.
Mhm.
The argument is frequently made that city streets are clearly dramatically more difficult problem than highway driving is. And that's true in some respects, but it's not true in all respects. And one of the ways that it's not true is that a bad outcome at 70 miles an hour on a rural highway is a lot worse than a bad outcome at 15 miles an hour in a crosswalk, right? In general, looking at those two.
Yeah, I mean it's complicated because on the freeway you won't have usually pedestrians crossing the street, But let's say,
On rural highways, you do,
well,
actually.
yeah, that's true, but not as frequently as, for example, a city,
Yeah,
or
yeah.
like a local city or town center. You have lots of people
but
crossing the
but in
street.
proportion, right? It's
Hmm.
a lot harder to detect them. If you a pedestrian crossing, a rural highway at night, and this does happen, right?
Hmm.
In lots of places that you can drive your Tesla. Uh, the the neural networks are going to have a lot less training data on that situation. It's already a handicap, and the 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 worst accidents we've seen in Teslas were these kind of rural highway sort of situations, right? Those are the another argument that you frequently hear is that city streets are a lot more deadly than highways are, and that's actually not true. Limited access urban highways have pretty low fatality rates, all things considered, especially when you look at the number of vehicle miles that get driven on them. But rural highways actually have the highest fatalities per mile driven. It's much higher than city streets are. So, and rural highways are a great place to use your Tesla. There are fewer Teslas in that environment, so there's less opportunity for the fleet globally to have accidents there. But it's a very big risk spot for Teslas. And in fact, the first really terrible accident that we had was a rural highway in Florida, right?
Hmm.
It was a pretty gruesome accident. It was an event that I think the self-driving community was very concerned was going to change the public's attitude about this technology. And luckily for us, people are reasonable. It didn't change public attitudes very much, and it sort of worked out. But I bring it up because it's an example of how the perception that city streets are just a completely different beast in terms of how risky and complicated they are from highways. That's really not true. The disadvantage of moving at high velocities and having less time to react is actually a very big disadvantage that
Yeah.
highways have that city streets don't.
Yeah, I mean that's exemplified, like for example, with Waymo's approach. They're like, "Hey, let's geofence more of a local area, cap the speed at like whatever
Mm-hmm.
35 miles per hour." So because you cap the speed, the velocity shrinks, and therefore it's a safer environment in that sense where you're not going 70 miles per hour in random places. But then if you geofence it and you map everything and you kind of like figure out all the quirks in that local space, then you can just look out for certain things, like for example, a pedestrian going that way or this way. And so, I mean, obviously Waymo's approach has major, I guess, challenges because, and we can talk about that maybe, later on in the video, but yeah, they're not using like, I guess, they're not necessarily solving for passive optical or a generalized, a solution for self-driving. It's more like, hey, let's map everything out. Let's, geofence it and let's solve this problem at a certain speed, low speed, and then gradually increase that speed and gradually increase, the geofencing.
People will point out that Waymo's vehicles, they also get on freeways, and the ones that they're operating, Chandler, Arizona, they do fine in those situations also.
Mm-hmm.
I would not make the case that city street driving is easier than driving on the highway. I would not make that case. That they are different in some really important ways, but similarly, it is frequently the case is frequently made that city streets are dramatically more difficult than highways are, and I think that is also not strictly correct either. Highways have challenges that city streets do not have, and they're very important challenges, and they're specifically important in the sense that they have a very serious risk of serious injury because of the speeds involved and the reaction times that are
Sure.
involved.
I want to. Oh yeah. I want to talk actually. I want to talk about the rewrite that Tesla has done with their full
Okay.
self-driving. So why do you think Tesla was kind of forced to or decided to do a rewrite, and how big of a rewrite was this rewrite, and what are the
Pretty big.
what are the implications of this rewrite? Is this going to help Tesla reach their goals faster, or for full self-driving to be safer, quicker?
Yeah, it's definitely going to be. So, frequently when you're in an organization and you're looking at, do we continue to iterate on the platform that we have that's mature and we know what it's doing, or do we take a step back and we and do the rewrite? It's almost always the case that that there are these things that are fundamental things that if you go to the effort of changing them, your system is going to get dramatically better. The risk is like how you've got to divert these resources and you have to take this time out to go back and do this. But having done it, it's almost always a win. And I think it's almost certainly a win for Tesla. It's a the rewrite is a substantial change, both architecturally and in terms of the total amount of computation that's getting done. The size of the neural networks has expanded, and the number of neural networks has expanded quite a bit. I've just this weekend, I finally got a chance to look at neural network flow diagrams to see the architectures of this stuff, and I've only got some sort of preliminary understanding of what's going on there, but it's clear from what I'm looking at that they've got multiple complete sets of networks that they swap out depending on the situation that they're in, that the individual sets of networks, each individually, is much bigger and much more sophisticated than the network that they're running in AP2. And I mean, you can look at the FSD videos and you can tell that they're getting their money's worth for this thing. The FSD videos are really clearly demonstrating that the situational awareness of the rewrite is significantly better than the situational awareness that they're able to get in AP2. And this is probably because, they've had a significant side effort going on for a year or 2 years or something like that essentially broke off a fork of what they had 2 years ago and expanded it specifically with the intention of only running on hardware 3, allowing the networks to get a lot bigger, relying on a lot more training data than they're using in the previous system, maybe dialing back some of the features. When I look at the system right now, it looks like that the system that they're using on the highway is still pretty similar to what they had before, although expanded, but that the system that they're using on city streets is actually a different system. Like they swap out the neural networks and they change the perception behavior. Like it looks like they use a different set of networks depending on whether they're driving, stopped, or at a crosswalk, right? That they've got these different systems that they use depending on what the relative trade-offs of like what things they need to do well in a particular situation that they're in.
I'm wondering, like, with this full self-driving rewrite, I mean, in our previous conversation we had, you were talking about one of the big things of this rewrite was they had to do camera fusion. They had to bring all of the cameras together to kind of create one view. Before, they were, I guess, having separate camera views for all the different cameras, and that would lead to inaccuracies or overlap that could be confusing. So could you explain kind of why that was important for Tesla to do this rewrite, to bring in camera fusion, one view, and what that means for kind of full self-driving? Is that going to help the pace of improvement for full self-driving really in the future?
So I think it was possible at some point a couple of years ago, before, when they just had separate cameras, to not be, so there's an example that I like because it's one that as a driver that you can see pretty simply. You stop at a light and a semi pulls up next to you, and then you look down at the display, right? And the car shows you 2 big trucks next to you instead of 1. And why is it showing me 2 trucks? There's clearly only 1 truck.
Or sometimes the truck would be like moving back and forth or something. Yeah, I know you're talking about.
They move around a lot less than they used to, but you still get it's not sure if it's 1 truck or 2 trucks. And the short answer is, you've got these wide field of view cameras that are like 4 feet from this truck and they're looking straight at the side of it. As a human being, if there's a semi next to you, it's actually really hard to judge the distance to the semi because we look at the boundary edges of things in order to understand. But if you've just got this white wall that you see out your passenger window, right? Knowing whether that semi is like 4 feet from you or 6 feet from you or 8 feet from you, it's super hard to judge. And that's also true for the cameras, right? A camera that's looking pretty much straight out the side of the car, the pillar and repeater cameras, they both look sideways. One of them faces sideways and forward, one faces sideways and backwards. So you've got these 2 cameras on the side of the thing, and neither one of them individually can make a decision about where the boundaries of the vehicle of this big truck are that's next to it. And that's just a consequence of having multiple cameras and having the coordination between them be limited, right? In the old system, each camera was asked, tell me what vehicles do you see, right? And when there was an overlap, there was this heuristic code at a high level that would try to correlate those two, where it would say, oh, this truck being seen by this camera and this truck being seen by this camera, they're probably the same truck. Let's assume it's the same truck, right? There are going to be situations where that doesn't work. And so the system is misunderstanding the situation and thinking, oh, it's 2 trucks instead of 1 truck. And that has material impact on driving decisions, right? Because if it's 2 trucks, then the tail of the truck in front of you is just in front of your car, and that creates a different set of situations in terms of whether that car might cut in or whatnot than if it's immediately next to you. You have a different set of sensor modalities for understanding what's going on if it's 1 versus 2. When you do fusion, you bring all the cameras together and then you decide how many trucks there are. And so one of the things I've been looking at in the video is like, is it making these kinds of mistakes now? Is it misidentifying vehicles? So a pretty common misidentification that you see in AP2 is like when you're stopped or you're being overtaken by a vehicle, and behind you it's one kind of vehicle, and it comes alongside and it changes into a different kind of vehicle, and then it passes you and it becomes yet a different vehicle. Like you can see that the system's perceptions are changing as that vehicle transitions from camera frame to camera frame, right? One of the things that it seems to me, looking at the existing FSD videos, is it's not making those mistakes anymore, right? The vehicle varieties and vehicle, like you don't see vehicles boundaries changing dramatically as they move through the fields of view of the camera around the car. This is a especially big deal at intersections, right? Where you've got 3 forward-facing cameras, and then both of the pillar cameras are also they're heavily utilized at intersections because the forward-facing cameras, they can't see down either of the adjacent roads. And it's very important to have a good understanding of what's going on in those down those 2 roads. So you're relying heavily on the pillar cameras. The fact that vehicles transition across an intersection in front of the FSD beta and they don't change as they go through. And you can see videos where somebody's sitting at a light and you watch 50 vehicles go through, and it's completely consistent in terms of not only the vehicle identity, but you don't see these big transitions as the vehicles go across where it has a different estimate of their velocity or a different estimate of their relative position or distance or whatnot. It's quite consistent on these things. And so I look at that and I get, my takeaway is that camera fusion is working well for them, and it's solving important problems that they didn't have when they didn't have camera fusion.
Yeah, it's interesting because since our conversation last week, I was thinking like when you were talking about fusion and how important it is, I was thinking like Elon and his team probably had a decision where without fusion, before, let's say over a year ago, they could have released full self-driving and it probably would have worked okay, but it would have had some glaring, I guess, weak spots or holes. And eventually they would have needed to do camera fusion and a big update and rewrite. And, Elon might have been tempted to just push out FSD to get like the incremental revenue that, they're still like, holding on to in their books. And it could have helped out Tesla's, profit, et cetera. But I think he chose to say, hey, we're going to have to do this rewrite anyways. We're going to need camera fusion to make things safer. It's going to push out our, rollout date a bit further, but let's go ahead and do the right thing. And so I think like when I look back at it, I'm like, yeah, I think, it seems like Elon and his team are just, especially with autopilot and just how things are progressing, they're making the right decisions in terms of kind of what needs to be done and when things need to be rolled out. And like some people might criticize Tesla and say, oh, Tesla's being reckless. They're not doing enough, driver monitoring or this or that. But I think what's underappreciated is how much attention goes into like trying to make the safest system, that they can roll out in a responsible way, And I think this whole rewrite and the beta, even though it's coming late, I think it is a much better product, than Tesla could have released a year ago, and largely probably because of this rewrite and the camera fusion.
So the more aggressive Tesla is in pushing this stuff out to the field, the faster the development of the technology is going to be. Not just because they can collect more data from vehicles in the field, but because more people are interacting with it. They're getting a lot, they're getting more long tail examples, they're getting more extreme case examples, and they're just generally everybody driving the car who does interventions, that's the richest data feed that Tesla gets, is the interventions, right? I mean, what the cameras send back is really important in its own right, but the interventions are a very valuable way of labeling things that need to be addressed in the system. And you can look at those interventions and you can get really important metrics about how you're doing overall. That lets you make trade-offs between, do we need to focus more on this or do we need to focus more on that? The example of camera fusion, I think the argument for Tesla to be aggressive is that it will meaningfully accelerate the day when these technologies are out there saving lives, right? So, in the U.S., like 40,000 people a year die because of highway accidents, but like 500,000 people get sent to the hospital, right? It's not just mortality, and then there's like trillions of dollars in property damage, right? So, in a sense, if this was an on-off switch, if there was a day when this is widely available and the day before it wasn't available at all, every day you delay is another day of carnage. And this is just the U.S. I mean, in other countries, it's even worse. The U.S. system is actually relatively good. You look at, third world countries, man, the highway fatalities are just insane. And they won't get this the day that we get it, but they probably, when they get it, is probably gated by us getting it, proving it out, and getting it mature, right? So it's, if you're at a company that's developing these technologies, right, you kind of, on the one hand, you have this choice about, if we go too fast, some people might die, or some people might be harmed, or the property might get destroyed as a direct consequence of our decisions. But it should be equally true, and it should be more important that every day you don't do this stuff, the world is also suffering in a really serious way. So if I look at, well, I can be conservative, and I can take it'll just take me 2 years longer to get to market. 2 years, that's worldwide, that's 1 million highway fatalities. And that's like, 50 million people that went to the hospital that if you had the courage to go fast, or to push the envelope, and the willingness to take some blame and be wrong some, you could have made a big difference in the world. Right.
Yeah. I mean,
so I think properly, those two things ought to be balanced somehow
yeah.
in what's going on. And the second one gets left out of the discussion a lot these days, right? I mean, back when, 10 years ago in the self-driving community, that was a big thing. Like, we're on a mission to get this stuff out there because it's going to save a lot of lives. It's going to make the world a better place in a really meaningful way. But right now, a lot of the dialogue about this is just like, how do we do this and make sure that it's never our fault if somebody dies, right?
Sure. I think it's like difficult for a lot of people and companies to hold these two somewhat opposing principles or ideas, like being aggressive and being conservative at the same time. Like, typically people and companies tend to err on one side. Like, it's hard to hold two opposing values together. That's why I think for a lot of self-driving efforts, you can characterize them as one or the other. Many of them may be too conservative, but I think with Tesla, what's interesting is you can't really say, in my opinion, like Tesla is being too conservative, or it's like necessarily just flat out being too aggressive. Like, they actually have an interesting combination where they are very aggressive in certain ways, and how they've rolled out technology and what they're doing. They're pushing the envelope. So you can't say that they're not being aggressive. But then in a lot of ways, Tesla is being conservative too. They're really prioritizing safety. And so you can't really knock Tesla completely, saying, oh, Tesla is being way too slow, way too conservative in that sense. I mean, there's a combination, what I'm saying, with Tesla, where they're being super aggressive, but yet they're being, conservative in their own sense in terms of, prioritizing safety as well. I think that's kind of misunderstood or not fully grasped, and how difficult that kind of holding those two values together is. I think a lot of companies might just err completely on one side or the other.
Yeah, I would differ slightly in my opinion on that topic. I think they're being too conservative. I think if we look back at all of this stuff 10 years from now, and we look at the difference that this is going to make in the lives of people around the world, and you ask the question, should they have tried to make it happen 6 months sooner? I think the question is going to be clearly, oh yeah, it definitely, that more risk should have been taken, right? But the thing is, if you're managing a company, right, all of the direct risk to your company is all on one side of the equation, right? No matter how many people die in car accidents unassociated with your company this year, it's got no negative impact on your company, right? But every single accident that happens as a direct consequence of decisions that you made, or that's at least attributable by the media to decisions that you made, could have dire consequences. And so all companies, and I think Tesla's in this, I think Tesla's less conservative than many of the other players in this space are. But I think Tesla is also being extremely
Yeah.
conservative in this space.
So actually, I like this disagreement because I mean this is
Mm-hmm.
where I think interesting insights always come up from. I would actually disagree that Tesla is being too
Mm-hmm.
conservative, and the reason is
Okay.
because I think Tesla is keenly aware that this is not just a technological issue, meaning it's not just a tech problem, a machine learning problem to solve, etc. If it was, I agree, you go full blast. You don't care about opposition. But I think Tesla is keenly aware this is also this is a very complex issue. It deals with regulations, regulatory bodies, and it deals with public perception, and it also deals with
Yep.
media coverage, and it's extremely like one of the key things that could really set full self-driving, autonomous driving back many
Right.
years is an onslaught
That's
of negative media that's
yeah.
highlighting certain gruesome accidents that just like, and
Right.
combine this with millions, if not
Okay.
billions of dollars of short
So
interest
that
money backing
argument
that up.
has
Um,
been dominant for a really long time in the self-driving space,
mhm.
right? Like literally right back to the beginning of when people were seriously working on this problem. That whole question of like, if we blow it and there's negative public perception, it'll slow this down. And I believed at the time, like I took part in some of those discussions at the time, and I totally bought into that perception. We don't know how the public's going to respond. When you look at newspaper articles, people are really uncertain about this. There are all these people who say they'd never ride in a self-driving car. You see these polls and you get an impression that the public is really quite uncertain about this. And I think it was very reasonable to hold that perspective right up until we actually had some accidents. Okay, so we've had a couple of accidents now, and we can look at what the public response to those was. And my read on the public response is it's very different from this legitimate, but in retrospect, overly conservative concern that the public will have a strong negative reaction if these things don't go really well. So there was the Brown accident, right, back in 2018, which was grisly. The self-driving community outside of Tesla had a complete fit over it because they're like, oh God, we've worried about this for 10 years. And now it's finally come, the whole industry is coming to an end. Nothing happened, right? It was just a big, people tried to make a big deal of it and the public mostly didn't care. It just went by. And then even more kind of dramatically, we had the Uber accident, right? In Arizona, 18 months ago, 2 years ago or something like that. That was an even better test case. It got even more attention. It was in a lot of ways, it was an even more egregious failure, right? It was much more attributable. And I would argue that the public response was much the same, right? You didn't see senators up on boards, seriously making an effort to stop all this kind of stuff. There were plenty of media articles that came out that were harsh on this, and the public pretty much just let it go by. Like nobody that I know who isn't intimately familiar with the self-driving community actually had any closely held, powerful opinion about this at all. Like to the public at large, that just went completely by. And I think that response should be assigned to us that the self-driving community has been too conscious of this concern for too long, that the public is relatively accepting of imperfection in safety systems if in general they're an advancement. And so I've worked at a lot of different companies. I also worked at a company that made airbag crash sensors back when that was a new thing. And those guys had a pretty tough trade-off, right? They were making this sensor that went in a car that would have to detect when to fire the airbag. Now, it's got to decide really quickly because you only have an instant between the time you hit something and the time that airbag's out to deploy if it's gonna help people, right? But airbags, especially at the time, they're pretty dangerous, right? If you accidentally, having an airbag deploy in your face is not a nice thing, right? It's like getting punched in the face really hard. People frequently have skull fractures, they get teeth broken. Frequently there's eye damage. There's all kinds of bad things that can happen. Small women and children were being killed by airbags at the time. So if you were making an airbag sensor, you definitely didn't want it to fire off accidentally, right? And now airbags were mandated. There were regulations that came and said that, you had to start putting these in cars, right? Automakers didn't want to touch that because they didn't like the idea of like all the negative press. Like it's one thing for somebody to die in a car accident. It's another thing for an airbag to go off in their face and you to be the reason that the thing that that it happened. So in a lot of ways, it was a very similar. It was a very similar situation. The industry were super concerned about this stuff, and they were super price conscious too. And the people I knew who were working at airbag crash sensor companies, they spent a lot of time trying to figure out how to make the sensors better. And what they discovered very quickly is like, no matter how much better the sensor got, if it cost a nickel more, you couldn't sell it, right?
Mm-hmm.
They were, car companies were only going to buy the cheapest sensor you made, right? As long as it just scraped by and was good enough. So they had this complicated trade-off that they had to make, and they were super concerned about public response to this kind of stuff. But the public response in general, I mean, media coverage was one thing, right? But the actual public response to airbags was generally, these are safety systems, they're good, we accept them in cars, they're not perfect. There were a lot of grisly failures that involved the death of infants and young women, right, in these things. And yet we have, we look back on time and you say, well, would the world have been better if we delayed airbag introductions by 5 years in order so that for those things to never have happened? I mean, even if that was possible, which is probably not.
Yeah.
Even if it had, not very many people today would say, yeah, we should have delayed airbags by 5 years. That would have been better.
Sure. Actually, yeah, this is great. Because I don't think this type of conversation or discussion happens as much as it needs to happen. I actually disagree with quite a few of those points.
Okay.
And it's great because I don't get to share these thoughts, unless like we have a random conversation like this. But yeah, on some aspects, yeah, I agree that, for example, the previous autopilot Tesla accidents haven't received the backlash that maybe some people were worried about, but I think, like, for example, and I think a large part of that reason was Tesla has, constantly and consistently been telling people you need to have your hands on the wheel, you need to be attentive, etc. And they've over time increased, the warnings, etc. for people. Regarding the Uber accident, I have a different opinion on that. And I think the public outrage and the media coverage was extremely, extremely negative on that. It shocked Uber to a lot of degree, and the reason why they were able to, or we were able to move on from that, is because of it was later footage where I think it was shown that the driver wasn't even paying attention during that time, and that's what led to the car. I guess he wasn't monitoring as he should, and in that regard, like, the public was like, okay, it was his mistake, right? And it kind of like, you can maybe move on from that a bit. I think there's extreme difference, for example, with autopilot AP2, where you have the responsibility on the driver to be constantly monitoring, let's say, the vehicle, and let's say you're constantly monitoring the vehicle and you get into accident and you kill yourself. That's one thing, okay? Or I want to say you kill yourself, but in that accident you die. Like, there's something about when you're driving and a mistake is made with your car or your driving skills and you kill yourself. That's one thing where people can understand, something about that whole situation is that person's responsibility, or that person entered some type of contract, let's say, with that car and that software, or whatever, understood the risks. Therefore,
it's
they
not
can
the
understand.
Car's fault.
Yeah, exactly.
It's the driver's fault.
And whether, even if it's the car's fault, the owner bought that car, and understood that they're buying that type of feature, and they take those risks. However, I think it's a different situation when it's killing someone else that wasn't part of buying that car or deciding to choose those features, right? It's a random person, say, walking on the street. They're killed by a car, and now it's important, like, is that car, can we attribute responsibility? Was that person being reckless? So usually you can say, hey, that person was being reckless, he was drunk, or he was on his cell phone, or he didn't see the red light, etc. And you can blame that person. And there's a legal system and a justice system and a financial system for that type of case. However, in the case of autopilot, or let's say full self-driving on local streets, there's two situations. One situation is the driver is monitoring full self-driving, decently well. He's not like completely like on the phone or something. He's doing decently well. And yet while he's monitoring it, like, it kills somebody. Okay. So that's one situation. The second situation is a person's doing full self-driving, 5 or 10 seconds, they're kind of looking down or something, on their phone or on the screen or something. And in that 5-second period, they kill somebody, let's say, with their car. Now, I think, like, that 5 to 10 second, you're looking down, I think the public is more or less going to be okay and move on with that, because they're saying, hey, Tesla has told the driver to always have their hands on their wheel, et cetera, to monitor it. Therefore, it's the driver's fault. I think the complicating thing is if the person was actually monitoring it and it actually like made a mistake and killed someone, like that's harder to explain because then it's like, it's like you have to blame the car, but then it also leads to this other situation where how is Tesla going to move from the whole driver monitor, the responsibility of the driver, to now where the driver doesn't have to have responsibility, right? And when that happens, that shift to the car taking responsibility, any accident that, let's say, kills someone in that situation is going to be blamed like on the car. And
it's Tesla's responsibility.
Yeah, it's Tesla's responsibility. And
right.
What I'm saying, and I guess the bigger picture of this is it's different in my opinion than seatbelts in a sense, because this is something where it's like or not seatbelts or airbags, right? I think you could make a case objectively that even though there are like less, you can make it, even back when airbags was more controversial, you could say, oh, the number of lives saved by airbags is far greater, let's say, than the few accidents. However, with full self-driving, you're comparing it to people driving. So the ability of the full self-driving computer needs to be significantly better than the person driving in order to make that argument. If it's not, then you have a very kind of dangerous situation where people have the right to say, hey, I question this, whether we should allow these cars even on the road until they get to the point where they're way better and they justify the risks of, self-driving.
Yeah. When I suggest that Tesla is not being as aggressive as they could be, as would probably be best in the long term for the world, it's important that Tesla survive, right? So for them to take existential risks that could potentially put them out of business, that's not a win, right? I believe that there's good evidence that they could go faster and they could push the envelope a little bit more while they're still in the zone where you have this we can break this up into kind of phases. We're in the phase right now where a human being needs to be supervising it, right? And if something goes wrong, it's the human's fault. I mean, aside from the possibility that the company does something completely ridiculous, right? And as anybody who's driven AP a lot, certainly I would say this. I think most of my acquaintances would say this. If you're paying attention, it's not possible. AP does not do things that could put you at serious risk of an accident if you're paying attention, right? You always have plenty of read on that. So there may be some people who disagree.
Yeah, there
might
be. Actually, there's some people. It's happened once or twice to me, but anyways.
It's I have a friend who made this assertion once, who also has an AP car, and he's like, oh, I was driving along and there was this thing that happened, and man, if I hadn't really been on it, we would have been right into the boundary. There was an interesting thing. I was like, man, that's so inconsistent with my experience with the car. He had a dash cam in his car, and we went back and we looked at the dash cam, and the reality was he wasn't paying attention, right? He got surprised by a situation because, it was clear from the dash cam video that you could tell that something was happening 5 seconds before it happened. And it surprised him because he'd been zoning out for 4 of those 5 seconds. So it seemed like a sudden thing to him. But when we actually went back and we looked at the evidence, it wasn't. And after that, his opinion on the thing completely changed. And he didn't actually review the dash cam video for several weeks after this when I was poking at him, really. Did that really happen? Because that's very different from my experience with autopilot. We went back, he dug out the dash cam video, we looked at the thing, and his opinion went from, oh my, this is really dangerous and you really got to be on it. Maybe people should use it, to, oh, I feel like such an idiot. Why did I do that? I think
as
a driver, this thing happens all the time. People zone out, something catches you by surprise, and your memory of it is that it happened really quickly and there was almost nothing you could do, and it was a really, really close situation. I'm unaware of any situation like that where there's objective, evidence maybe you can examine afterward that support that.
Maybe you can help me out, kind of reinterpret some of my experiences on autopilot. So, and I haven't driven as much this year. I've been on the road doing RV travel, but I've driven a good amount of autopilot in 2018 and 2019 on the freeway. So there are times, and Tesla might have changed this, since then, but hopefully you can shed light. So there are times where it feels like I'm on the freeway and then I'm taking maybe it's like a on-ramp or freeway transition to another freeway, and it's a very curvy road. It's like almost 90-degree like turn,
Mm-hmm.
and it's quite fast. And let's say I'm going even like I've set the speed limit to 10 miles even faster than the speed limit, so it's going quite fast. I'm going to say 75 miles per hour even, and it's going on this 90-degree angle. So a few things. One is, let's say the the angle might say like the speed limit is 55, but maybe autopilot didn't catch it that it was 55, so it's still going 75. But let's say even if it caught it, so it moves it down to, let's say, 65 miles per hour or something. I'm going on it, and then it's like sometimes it's going so, and I think recently might have fixed it, might be different, but a couple times, this is maybe a few years ago, but it was going so fast that I could feel like kind of the car moving more too close to the edge, right, to the far
Mm-hmm.
edge, feeling like, oh my gosh, this is going to pull me out of the lane. And then um, so most of the time I'm having to be like, okay, I need to reduce my speed manually on these like more
Mm-hmm.
sharp turns in order for it to handle it better. But there are one time or two times where it felt like it actually like disengaged. It was like it couldn't handle the turn. It was just like too sharp
Mm-hmm.
of a turn and disengaged. And I'm like, and at last minute I have to take control and pull it away. And
Mm-hmm.
I know that if like I was just like,
Not paying
what,
attention.
either not paying attention, or if let's say I was like 80 years old and had much slower reflexes, even, you know what I'm saying? I have pretty fast reflexes as a person. I could quickly do it.
Mm-hmm.
But let's say, yeah, I don't have that type of reflex system. I'm not anticipating it. See, that's the thing. I'm anticipating it as I'm going around a sharp
Right.
turn. But let's say I'm
Because
not.
you're paying attention. Yeah.
Well, even that. Let's say I'm older. I'm 80 years old. Let's say I'm paying attention, but I'm
Mm-hmm.
not anticipating that this car can disengage on a corner. I don't even know that can or not, right?
Mm-hmm.
And so I'm just doing my normal thing. I'm 80 years old, and it goes around this sharp corner, but it disengages because it's too sharp.
Mm-hmm.
Like I might not have the the reflex time, right? And the will to move it over that quickly. I do, in my case, but I'm saying
Mm-hmm.
to extend that to everyone on the road, I think is kind of a little bit more optimistic. I don't know. What's your take on that? Is that a situation that I'm just like misjudging or misinterpreting, or is that like some type of realistic, concern?
Okay. I think human beings actually do a really good job behind the wheel in general, right? I mean, you look at, we've got these 3,000, pound death machines speeding down these highways, and they're just a couple feet apart. It's pretty impressive how well our road system works, and on top of that, how good people are in general at judging their own limitations and making and so 80-year-olds tend to drive a lot slower. They tend to give people a lot more space. They tend to be much more conservative drivers. People who can't see well, people who are impaired, who aren't feeling well, they slow down. They account for this kind of stuff. If you have somebody who is impaired and is ignorant of they don't, if they're impaired, they don't have, they're unfamiliar with the system, and yet they're going to use it at its absolute limits, right? I believe you can construct scenarios where there may be bad outcomes. I just don't think those are realistic scenarios.
Well, think about it though. Like, does Tesla say I mean, here's the thing. Let's say navigate on autopilot. Does it really take into consideration the person's age, the person's reflex times, the person's, like all this stuff? Or is it just it's kind of like this standardized solution, considering that everyone has to be like, super attentive and super like fast to respond? And, and,
As
and
long as,
and
sorry,
if let's say the system doesn't take in consideration each person's situation, then isn't that a weakness in the system?
so for a fully automated system where you're telling people they don't need to pay attention, or where if you're relying on the driver to intervene and uh, and you're putting the driver in situations where they can't intervene and where the driver doesn't have the ability to like increase the safety margin, then yeah, I just don't think that people don't get to increase the safety margin, that they can't, that people who are experienced with the systems. I've watched plenty of beginners get in Tesla autopilot systems and drive them around, and they're crazy conservative for a long time. They use the system, until they get comfortable with it, and they tend to only use it inside an envelope that they understand quite well. If that weren't the case, if people tended to get in, believe the literature, hit the button, read a newspaper, if people were, I'll say, reckless, if people
Yeah.
were much less conservative, maybe more graciously put, than the system, then it could be, a much bigger real world problem. And I would not dispute that there are some, people who are clueless who will engage in that kind of behavior. I just think they're rare enough that you don't design your policy around those people. Just, you also have this thing, which is kind of interesting with Tesla vehicles, where people can misbehave with the car. You can find YouTube videos of people like getting out of the driver's seat while the thing's on the highway and that kind of stuff. So a question that occasionally comes up is, should Tesla design the cars so it's not possible to do that, right? And I would argue to some extent they do. I mean, there's certainly safety systems in the car. Like if you're going to get out of the driver's seat, and it's because you have physically disabled some of the safeguards that the car has. Anybody who has a car knows that basically you can't get away with that. You have to rig the car somehow. To what extent what set of safeguards do you have to put in place to make, let me put it this way. If you raise the bar for malfeasance to a point where it's simply impractical, you have to find a way to do that without reducing the utility to the 99.9% of the people who are using it faithfully. If you make it harder for them to use and you reduce usage of a safety system in a car in order to not have some embarrassing YouTube videos, that's not really the right decision, right? You want to make the decision that is best for the most people. And if most people, to some extent, bad actors, they're going to act bad, and it's really hard to stop them from doing it. If bad actors are super rare, then don't design your system such that good actors are disinclined to use it because it's inconvenient. Like there's the nag thing, right?
Sure.
I mean, the more naggy you make the system, the more attention it forces people to pay. Right. And if you've driven the system, the AP, for a while, you can see that the levels have gone up and down quite a bit. And it now seems to have an adaptive nag system, right? The system notices when it's in situations where you need to pay more attention, and it nags you more. And in situations where you don't need to pay as much, it nags you less. If you raise the nags to the point where people don't want to use the system, and there are people who in the past have crossed the threshold where they found the system was nagging them enough that they just didn't want to use it, that doesn't end up being a win because it's a safety system, right? There are fewer accidents when people use a system than when they don't. So that's a calculus that you have to do. And the weighting is overwhelmingly on the side of people who are well behaved, because people who are driving cars, they don't want to die in accidents and they don't want to kill anybody. Yeah. Overwhelmingly, yeah. Right? They're people are reasonable.
Yeah. I mean, overall, I agree, and I think we're not too far off. I mean, we both agree on the importance of pushing things forward aggressively, because I do agree there's massive benefits to self-driving autonomous technologies, and we do see some risks in terms of mishaps and different situations coming. So there's definitely I think a balance that needs to happen, and it seems like you might think Tesla can go a little bit faster, which is possible. I think in my perspective though, like there's a few other angles, which is like there's a massive Tesla Q FUD kind of media against Tesla. There's money against what Tesla's doing, where people right now are like all utopia, hype Tesla stock, but they think that the anti-Tesla folks are just gone, right? But they aren't really gone. They're just kind of a little bit dormant. And it doesn't take much for big money and for media and for a coordinated campaign to happen, where they go after Tesla big time on let's say a series of mishaps that happen that could really impact not necessarily Tesla's technological focus and their execution per se, but could impact the perception of not just the general public, but of the regulators who are going to decide on this. And so it could delay things. I'm not going to say it's going to throw it off completely, but I think there's a balance where I do think Tesla needs to tread, I wouldn't say slowly, but they need to go fast as they can in a way where they don't do existential mistakes or mistakes that completely like throw off the timeline by many years. It's, what do you think?
Yeah, so I should clarify this just a little bit too. I'm making the argument that I, I'm not trying to make the argument that they need to go a lot faster, right? What I'm trying to do is refute the argument that they need to go a lot slower,
Okay, got
right?
it.
By saying there's this argument on the other side and it also carries weight and it ought to be considered. If you asked me, if Elon called me up on the phone and said, should we go faster? Do you think we should really push the envelope? I would be super uncomfortable with suggesting that they do that because it's complicated. And there are these unknown unknowns, things that could go wrong. And I think it's really important that they succeed, right? Not just as an investor. I am heavily invested in this company, but I think it's a good thing for the world if they succeed. Like I really want them to succeed. I wanted them to succeed long before I had an investment in them because I think their success and I would love to see Mobileye succeed. I would love to see Waymo succeed. I hope Cruise succeeds because I think these are all things that if they succeed, they're a lot better for the world. I don't want any of them to fail. And I would rather not see any of them take an existential risk that seriously creates the possibility that they won't be able to succeed because I think this stuff needs to do. And, because I think it is so important, I myself would err on the conservative side on a lot of these kinds of things. But I think there is this argument that to be made that they're not going too fast. They're not being reckless, right? They could go a lot faster and still not be, clearly reckless at what they're doing. I think, and especially now with what I'm seeing from the FSD videos right now, my sense is that they have significantly notched up their conservativeness with respect to the features that they're willing to push out and let the public use. This is probably a good sign, right? The thing I'm most encouraged by was before I started seeing FSD videos, I wasn't certain that the reason they were delaying wasn't because they were running into technical problems. So my sense from looking at the videos right now is it is not about technical problems. It has been about essentially raising the bar for the level of polish they want on the system before they turn it loose on the public. And I think a lot of people will agree that with that decision.
Yeah. I want to ask your take on this Dojo training system that Tesla is developing. Elon has mentioned it. People have gotten excited about it, but I don't know if many people really know what this is. What does it do? Can you explain what is, Tesla's Dojo system? Why did they make it? And how will this help Tesla's full self-driving, autonomous efforts going forward?
So one thing about deep learning neural networks is that they scale really well with power and data, with the compute power and data. That is, one simple way to make any system better, to just improve its accuracy, is just make the neural network bigger and feed it more data and train it for longer, right? A lot of systems don't scale with just simply by throwing more compute power at the problem, right? Classical coding systems don't. Microsoft Windows doesn't get any better if Microsoft uses twice as many computers to write it, right? And most of the code in the world is like that. But there's economic limits to how big a system you can put in the car and how big a system that you can train on data. So you want to be able to economically train these systems. That means you need to do the most computation for a reasonable amount of money that you can get away with. So hardware today in the deep learning world it's in kind of an interesting place. Deep learning is a new enough tech that when it first came into the world, there wasn't any hardware built that was specialized at doing what it does. And in fact, the best hardware actually wasn't a very good match for what deep learning really needs to do. And that's why a company like Tesla can basically make their full self-driving chip, right? They take a relatively small team of guys, they give them 6 months or 2 years or something like that. They're not even working on the latest process node. And yet they can come out with a chip which is dramatically better than any commercial solution that you could put in the car. It's much lower power. It's going to be higher reliability because it's a better fit for this thing. It's dramatically higher computational capability. And this is because it's architected for doing exactly what neural networks need to do. right? So similarly, the training hardware has similar kinds of limitations in the world today. You can go out and you can buy tons of CPUs and tons of GPUs, and you can build an HPC, high performance computing cluster, and network all this stuff together, and you can do training, and it costs a certain amount, right? This basically comes down to how much money do you want to spend training your neural network, right? So if Tesla wants to keep making the system better, they want to keep increasing the size of the network, they want to keep adding more data, and that means they need to train bigger and bigger and bigger networks. They have another limitation also, which is that up to now, a very substantial fraction of the data that they use for training the network is hand labeled. So they've got this army of people who, this is not like Mechanical Turk people, right? This is people that have been trained to do labeling, to use internal tools at Tesla, and they go through this data and they evaluate it. You know, they do essentially markup on this data to provide training targets for certain parts of the neural network that are heavily dependent on this thing, or on this right now. So the amount of data that they can feed into the training system is limited by the number of people that they have to do this. And people are expensive. So you could have 5,000 or 500 of these people, right? But having 50,000, that starts to get really expensive. So if you want to scale up 10x or 100x, you need to find a way to leverage them. And one of the things, there is a way to leverage labeling, which is this technique that they've described, where essentially let's use structure from motion, or let's use some mature geometrically based computational techniques to take a whole bunch of data and video from like all the cameras in the car at the same time, and let's use it to construct a 3D scene. Let's have the human labelers label that scene, and then you can push all that data back to the original frames. So this will increase the productivity of labelers like 100 times, maybe 1,000 times. I think those are the numbers that have been mentioned.
Like,
and I think that's realistic.
Like the 3D kind of structure through motion, that's what Andrej Karpathy was showing at Autonomy Day, right? Basically like kind of this 3D modeling. And I think in our last conversation, you were saying like to do that on the car side is going to be just intensive, not really that practical. But to do that, let's say on Dojo side, is going to be, much easier, but also it's going to be where it needs to be, meaning they need that kind of structure through motion or 3D modeling in order to supercharge their labeling, right? So if I can paraphrase, you're saying like, hey, a label can go through that 3D scene, mark, car, mark cat, mark person, big truck, whatever. And then now that 3D modeling scene is actually comprised of thousands of frames, let's say, that made that up. But once they label it once, all of those labels will go back to the individual frames as labeling. And so it basically leverages their human labeling efforts, but immensely, right?
So the thing about using, it's called SLAM, structure from motion. And it's not the only technique. There are other techniques too. But they're techniques that don't fundamentally rely on neural networks. They basically take a bunch of frames and they use pretty straightforward geometric processing, which is, I don't know if mature, it's probably not good to say that it's mature, but it's geometrically based. So you don't have to like train a neural network to do it. You can train neural networks to help, and probably Tesla and other companies will start using neural networks to speed up SLAM. But right now, SLAM is very computationally intensive. So you get this stream of data from a car. A car drives through a scene, and you have all the data from all the cameras and all the other sensors in the car. And you want to build this scene that a labeler is going to label. Well, some computer is going to go crank on that for a long time. And then they're going to present the scene to a human. So now you've got two limitations. You've got how fast can my computer crank out these scenes, in addition to how fast my people can label them. These are both moving targets, right? Because the tools are going to get better and the computers are going to get faster. But one thing that Tesla can do now, or that they will be able to do with Dojo, and they're probably already doing this with, Amazon cluster stuff, or maybe they have a data center composed of, NVIDIA boxes or something. I mean, they've got some kind of infrastructure that they're using now. So they can do this to some extent. And to the extent that they do it, it leverages their labelers. So leveraging your labelers, being able to train bigger networks with more data on the back end, these are all things that are very computationally intensive, right? And so looking out, over the arc, because we're not done with this now, right? This is, hardware 4 is going to come out. There will be a hardware 5 and a hardware 6. The networks are going to get bigger and bigger. And 10 years from now, this technology is going to be dramatically advanced from where it is now. We're not going to get to robotaxis and it's done, because robotaxis are going to get better and better. If you look along that arc, it's very important to bring the cost of computation all along that arc down as low as you can get it. And right now, computation is a lot more expensive than it needs to be, because most of the computation is not done on silicon, which is specialized at doing neural networks. So Tesla has a neural network problem that they want to solve. It's all about neural networks. So, they could spend, $50 million to build a machine to build their own machine that has a certain performance, or they could spend $50 million and buy a bunch of NVIDIA boxes, or buy some boxes from Intel, or rent time from AWS and get less of that. So my read on Dojo is it's Tesla making an investment in infrastructure so that 2 years down the road, 5 years down the road, they're getting the most computation at the most economical price. And they also control their own destiny. I mean, one of the problems that you have with relying on cloud providers, which is a really attractive alternate way to go, is that somebody else owns a critical piece of your infrastructure. It's like leasing your car factory. You don't want to do that. You want to own your car factory. You don't want to lease it from GM, because GM is maybe a competitor in certain respects. Mm-hmm. And I think it's exactly the right thing to do. I've been arguing, like in the circles, in the deep learning circles, for some time, that we needed to get off of GPUs and we need to get onto accelerators as fast as we could. I was super happy when I saw Google go to TPUs, because that was the existence proof that there's a lot of low-hanging fruit in making custom silicon to do the neural networks. And Google's gone to, the second and third generation of that kind of stuff. You see some startups making this stuff, but there's no commercially available part that you can buy today, which is really deep learning specialized. And so, that's why Tesla had to make their own silicon for their car, because nobody else was doing it. And it's strange, but it seems like the economic incentives aren't really there to do it. Like the people who are in the best position to actually bring, these custom neural networking chips into the world, they're actually disincentivized from doing it, because it would compete with other businesses that they have that are already making a ton of money in this space, right? So Google's making their own silicon. Amazon has started making their own silicon. Apple makes their own silicon. Like a big chunk of the silicon that goes in Apple's phones now is a neural network processor that they use for adding value to a lot of things that the phone does, and that they can't buy from anybody else because nobody's making it. So if Tesla wants an HPC infrastructure for training these big neural networks, I think they looked at the world and they made the kind of the same decision SpaceX did. We'd be happy to buy it from somebody else, but nobody else is making it, so we're going to do the development ourselves. Mm-hmm. That's what I think Dojo is.
Got it. So you were mentioning in our last chat that this custom silicon for neural networks it's not the same chip as hardware 3 inside the cars, right? Or hardware 4. No. So this is customized and made for basically data center type of big applications, like pulled computing together, right? So how long do you think that this has been, like, do they have the chips, like these custom chips, running right now? Are they just slowly scaling this, or do you think it's like what point of the development process, and scaling process do you think they're at right now with Dojo?
So my read of Dojo is it's taking longer than they wanted it to take. And I think they probably got silicon getting first silicon, essentially doing an architecture, getting your first silicon back and whatnot, getting it running that's a necessary first step to getting this stuff going. But designing an HPC cluster is a whole lot of really specialized technology on top of that is not traditionally like Tesla's strength, right? They're having to grow a team that can do this, and those people are going to have to get up to speed, just like they had to grow a silicon team to make the silicon, right? And HPC infrastructure involves a lot of very specialized networking, all of these thermal issues that Elon has alluded to. That's a really big deal for HPC structures. And there's a lot of specialized tech and knowledge that goes into that. And I think Tesla's having to get up that learning curve, and it's going to take a while before they're able to deploy this at the kind of scale that's meaningful to their development efforts for FSD, right? Like having 100 of these things running in a back room someplace is not enough. They're going to need 1,000 or 10,000 of them. And you don't want to do that until you've put the effort into designing the thermal solutions, the power solutions, the network solutions that are needed to support this stuff.
Mm-hmm.
And that's just going to take time. And I think that's probably the long pull for them right now. It's not the silicon.
Mm-hmm.
I would guess they already had their first generation silicon on this stuff out.
Mm-hmm. Got it. I want to talk about labeling because I think most people don't really grasp like labeling, what it does, and I'm sure we can go on for like a couple of hours on what labeling is and the importance. But rather than that, I want to maybe just like focus on maybe I can share a bit of my understanding of labeling, and then you can kind of poke some holes or try to get some help me to understand it maybe a little bit deeper or clearer. So my understanding of labeling is you've got this neural net, and I think we'll isolate it to Tesla's perception system, so how it gathers the images and perceives the world. And so these images are coming in, and I guess with this new rewrite, we have a fusion, the camera fusion. So you have maybe it's decided what the truth is in terms of what's happening, and as it comes in, it's going through a neural network of different nodes, and it comes out with an output of deciding what's in that perceived world, like what cars are there, what kind of cars, and what kind of people, just all of the different buildings, etc. But the extent that this neural network can be accurate, can have accurate results, all depends on the labeling. Meaning, in and of itself, the neural network can't really find out anything about. It could maybe parse the different colors and textures and edges and shapes and all this stuff, all the objects, but it's not going to tell you that this is a cat or this is a person or this is a thing. That is all dependent on the labeling that's put into the system, which basically is the training of the neural net. So you're showing the neural net a picture of a person, and you show a picture of a person or different types of people like 1 billion times, and the neural net's going to pick up on all the nuances, and it's going to learn what that person looks like, what a person looks like in different situations. And it's going to become more accurate over time, the more labeling or the more, training you're doing to that neural net. And so applying this to Tesla's case, I think like Tesla has trained their neural net with all this labeling, showing their neural net and this training of what is what, right, over time. And it's gotten to the point where it's decently accurate and the big things. But there's this whole field where there's a lot of cases where it's just ambiguous. It's like, is that really a car under the bridge or this lighting situation? It's just some ambiguity in terms of perception. And the neural net doesn't have enough training or enough data or enough examples shown to them and labeled where it can accurately discern what exactly that is. But to the extent that Tesla over time can increase the training and labeling of what, for example, that unique ambiguous situation is, and not just one time, but let's say they have thousands and thousands of examples from user interventions, etc., where they're able to pull those images, and the neural net wasn't really sure what that was, but through, let's say, human labeling, you label 1,000 of those similar situations. Now the neural net is getting better. It's saying, oh, now I know that situation because I've been trained, in what type of situation that is or what that is called, etc. And so the big challenge for Tesla's improvement of autonomous driving going forward is it needs to teach the neural net more and more, especially these edge cases and March of Nines, these extremely kind of difficult, ambiguous cases. And the way they can do that is they take the data, especially let's say intervention data or situations where they know that their neural net hasn't really operated optimally, and they can take that and then try to label the situation better so that the neural net can get better over time. But the challenge is, I guess, if you only have 50 labelers or something, or 100, you're not going to be able to leverage the massive amount of growing data and growing amounts of training that you could do it if you have more unlimited or scalable labeling. And so what Dojo is able to do is it's able to provide a way where labelers can supercharge their labeling, not just individual frames, but now structure through motion 3D models. So their labels can now go through and train the system even faster over time, thus increasing the speed of improvement for autonomous driving. So in that picture of my understanding of labeling, how it applies to, let's say, full self-driving, like what am I missing something, or is that the gist of it, or what else can you add to kind of that understanding?
That that that's everything you said is basically right on. That so neural networks, there's different ways of training neural networks. Actually, there's a whole zoo of ways now. But there's the most fundamental way is a neural network. It's a transfer function. It basically it takes an input and it predicts an output, right? In the case of Tesla's networks, they actually generate thousands of outputs. They have many thousands of different things that they predict from every frame that comes in, or every set of frames that comes in from the cameras. They predict, where can I drive? Like, where can I safely drive? Where can I absolutely not drive because it's a cliff or it's a wall? Where are the lines on the pavement? Where is the crosswalk? Where are the signs? Where are the traffic lights? Which traffic light is appropriate to my lane? From here going forward, what is the smoothest path through the available space? And thousands of other things beyond that. Like there's these, they have these cuboids, right? Like every single object in the environment, which matters at all to the car, it draws a little three-dimensional box around it to figure out what the boundaries are. And those boundaries define a box that you don't want to enter, right? So like, a stop sign has a cuboid because you don't want to hit a stop sign, but then an animal on the road has a little cuboid around it, and all the cars have cuboids, right? They have like everything that's occurred. They label all that kind of stuff too. So the simplest way, and Andrej Karpathy has made statements along the lines of, yeah, we know there are all these other ways to do training, but this simple supervised training, it's the thing that we know works, and we know how it works, and we know how to make it work well. And so that's what we're putting almost all our effort into. They have things that they don't need labeling for. And like my favorite example of that is cut-in, because Karpathy gave a bunch of examples at Autonomy Day about exactly how they developed cut-in. The cut-in predictor is basically, if I'm driving in my lane, it predicts if a car in an adjacent lane is going to pull in front of you, right? Because you have to take action. And that was a big weak point that AP had until they got the cut-in detector. It was delightful to watch it develop over time and to hear from Karpathy how that worked, especially because it actually didn't require very much labeling, which is in contrast to most of the rest of the stuff they do. So when they started doing it, the car would take pictures, and a picture would sit in front of a labeler, and a labeler, they'd have this photo on the screen, and they're like, this is the center divider line, this is the, they would mark every single thing in maybe 100 different categories that was in the frame, and you would try to get the boxes around everything really accurately. Then what the neural network would do is it would have a lot of these examples, millions of them. Like, it's incredibly labor intensive to have a group of people go through all of this data and label it. And the neural network's job is it gets an image and it has to tell you all these things about it. And it has to give you the same answer that the human labeler did, right? And you give it a different image and it tries to do this. Essentially, with a neural network, every time it's wrong, and it's always wrong, it'll never be exactly right. It'll always be off a little bit. You can take that error and you can look at everything that contributed to that error in the weights in the neural network, and you can tweak them just a little bit in the direction of correctness. And it turns out if you have enough examples and you do this enough, the neural network will get really, really good at giving you the same answers the human being did, right? So when they were just in the camera, when they were only using camera networks, which, the camera networks, incidentally, the term I'm using, there's a big neural network attached to each camera, right? That processes directly it gets the frames from the camera, and then it does a bunch of processing, and it generates a few hundreds of different pieces of data that come out. And some of those pieces of data include, these are the lane lines I see, and this is where they are. And some of the pieces of data are like, these are the vehicles and pedestrians and objects of interest, and these are the cuboids around them. This is the volume of space they occupy. It predicts all that stuff for all of those things. So, at one point, they had a piece of software that took all these pieces of data from all these cameras, and then it would decide what the situation is based on that. And over time, what they do is more and more of that back-end processing is handled by other neural networks that train even higher level stuff. But the bulk of the data and the most important stuff is the stuff that comes from the cameras, and that's very labor intensive to label. This is what's called supervised training. Supervised training is where you have a whole bunch of examples and you're going to give them to the neural network, and its job is to produce the answer that you know is the right answer given the input that you know is a particular input. And so they take all this data from the real world. So an important part of labeling, and a thing that's not well understood about Tesla's network, or maybe it's well understood, maybe it's not well appreciated. There's frequently this kind of misperception that all the Teslas are out there just recording all this data and uploading all this bulk data. In other words, that the Tesla fleet functions as a video recording device that bulk produces all of this data that just then gets labeled and curated and goes in the system. And that's actually not what it does. It does something which is much more useful than that, which is once you have this basic system working, right? So say you've built your network and you've got all your labeled examples and you run a bunch of stuff, the developers, they will start seeing patterns in the mistakes that get made. Like a good example is, you're coming up on a bridge and it breaks because it thinks it sees a wall because of a shadow or something like that. And the way you fix that with supervised training is you look at places where it made mistakes. You take those examples, you have a human label them, so with the correct label, and then you train the network on those. And what happens is the answers the network gives you shift away from the erroneous ones and they shift towards the accurate ones, right? But in order to be able to quickly grab a lot of examples of just the thing that you're having problems with, what you want in the real world is you'd like to have a fleet of 1 million cars out there where you can say, send me examples of this. You send them a request. I want this. And they take them and send them to you. And that's what Tesla's got. They're not absorbing. The fleet is not a data collection thing. It's a look at the world and find examples of this particular thing that I'm asking you for. Because what Tesla needs is not lots of data. What they need is a very specific data. If I was to say, Waymo, give me examples of office chairs falling off the back of trucks, right? Like it's going to take, if all you've got is 1,000 cars in the world, or if you're just getting all this data from all these cars, imagine having to have a computer go and look through all of this data that's just raw feed from cars, looking for examples of office chairs falling off the back of trucks, because that's a problem that you're trying to solve. What Tesla can do is they can say, I want office chairs falling off the back of trucks. They can send that out to the fleet, and every car that sees an office chair fall off a truck, it grabs that footage and sends it back to Tesla. So these cars in the field, they're filtering the world. They're using the processors they have in them to filter every single thing they see when they're out driving, looking for examples of things Tesla has requested. They grab that example and they send it back. Mm-hmm. They're not just, they're functioning not as recording devices, but as they're sort of intelligently filtering the world to find things that Tesla has asked for and send them back. And that's really important. That's very different from just having a bunch of recorders out in the world.
I mean, it's because, I'll just continue on. The thought is Tesla, the neural network is able to pick up certain things very easily, or it's doesn't have a problem. You don't need a ton more data or labeling on the things that they're really good at. You're needing the labeling and the data for the things that you're not good at, because that's what's you're trying to fix, is those cases where you can make a mistake.
The capability is like a bubble that expands, right? And there's this, it doesn't, you don't want to be grabbing data there's no way you can get it yet, right? Mm-hmm. And there's no point in having stuff that's already inside your bubble. You want to be collecting data that's right at the boundary. Like you can kind of do it, but you can't do it well. Because if you can kind of do it, I can tell the cars in the field, if I ask, this was one that we saw, when we were looking at this, people who hack the cars, they've been seeing Tesla pulling this data for a long time, and they could take apart the triggers to look and see what Tesla was asking for. And there were all these great examples, right? But one of them I really liked was garages, right? And I think this was because someone had a hard time understanding when it was in a garage versus a parking garage versus, had just entered a tunnel or whatever the deal was. And it was interesting looking at some of the stuff that came back, because there are a lot of different kinds of garages in the world, right? And so Tesla was just like, send me pictures of garages, right? And the way that they do that, the cars can kind of recognize a garage. Like they'll see something, they'll say, well, maybe this is a garage, maybe it's not a garage. If they have no clue if it's a garage or not, there's no point in asking the fleet for it, because you're just going to get random crap back. If the fleet kind of knows what a garage is, but it makes a lot of mistakes, you can ask for all those, and humans can go through those. And if the data is 10% effective or 50% effective, they just throw all the not garage examples away. The others get labeled garage. They go into the training system, right? And what happens is, 2 weeks later, all of a sudden your system is really good at recognizing garages, right? Mm-hmm. And they just go down this list of problems. It can't do this. Ask the fleet, get the data, label it, feed it in. And this is Carpathy's data engine, right? Mm-hmm. They're like, we need this. Ask the fleet. The data comes back, people label it, it goes in, and Operation Vacation for them is the labelers stay in the loop and the system stays in the loop, right? But the engineers, they could go on vacation and the system keeps getting better, because they look at the next problem, the thing that the car can't do, which they learn from interventions, right? Mm-hmm. That's why the interventions are really important, because that's human drivers telling you, fix this, fix this, fix this. I had to intervene. They automatically pull that data out. They collate it to look for common phenomena. They figure out, some human being figures out what the common things are. They generate a trigger, send it to the fleet, pull the data, train the network, problem solved, go on to the next one, right?
It's interesting because what you're talking about in terms of, pulling the data, the footage that they need from the cars. It's interesting because my first thing is like, well, how can they pull something that the car doesn't even know what it is? Like, for example, a garage. But I think your example of like, they'll, even if they get recognized, I say 10% of the garages, they'll pull that, but then use that data and labeling, right? The 10% that they were able to put it back into the system. So then the neural net knows better, like how to, look for a garage.
Let me give you a little bit more detail on this, right? Okay. So the neural networks, all the camera networks, and they generate this thing called an embedding, which is it's a number that basically tries to describe what the camera is seeing in this very high dimensional space. Maybe, the embeddings are typically 2,000 to 8,000 dimensional vectors or something like that, right? So if you want pictures of garages, what you do is you take pictures of like 100 garages and you run them through the neural network and you look at the embeddings you get out for each one. And the embeddings, they will form a grouping in this high dimensional space, right? In other words, there will be a point in this 1,000 dimensional space, which is the garage point. This is what a garage is, right? The network's uncertain though. For instance, if I just ask it, tell me what's exactly at this point, I send this point, this embedding out to the network and say, send me stuff that matches this, you're only going to get stuff that exactly matches it, and you're not going to learn anything. What you do instead is you say, send me anything that's within X distance of this. In other words, if you think it kind of might be a garage on all of these dimensions, send me that too. And then a human makes the decision, the labeler does, right? So the system doesn't need to accurately understand what a garage is. It just needs to have a reasonable, kind of a vague idea of what might be a garage. And then you tell it how likely something is to be a garage. If the network thinks it's 90% likely to be a garage, send me all those. Or you can say, if the network thinks it's 5% likely to send me a garage, all those. So they can try these different confidence figures and they can mine reality for examples that are rich enough, that are things the network wouldn't have caught before, but which it should catch. And so we're going to add those to our labeled data, right? That's sort of how it works.
Got it.
That's how all of these neural networks, they're fundamentally probabilistic. Like when they categorize something, they basically, when it has a lane line, it says, here's a lane line, here's the probabilistic boundary where I think the lane line is. I think it's 90% likely to be here, but there's a 10% chance it's here instead. So what you want to do as you develop the networks is have them have higher confidence in the right answer over time. And so a tool that you always have to work with when you're trying to select data or make decisions about this kind of stuff is you're always getting these probabilities out. You can say, even if you think it's only 5% likely to be a garage, send it to me. Or, if you were doing the office chair falling off the truck, that's a really hard one, right? It might be if you said, tell me, if you think it's 90% probable that it's an office chair falling off a truck, send me that. And you're going to miss a lot of office chairs falling off the trucks because it's never that confident. But if you tell it, 10%, you might get a lot of garbage, but at least you'll get some office chairs falling off a truck. So you have something to work with.
And then
so you have to figure out what that is.
And then you can take that data, the real cases of
the
office
real
chairs,
ones.
falling off the chair, label them, stick them back into the system.
You can take a bunch of the ones that thought maybe this is an office chair falling off a truck, right? And you can stick those in your training pool, and you can say this is definitely not an office chair falling off a truck, and it also gets smarter that way.
That's true. So, and then Tesla pushes out an update, and now they're much better at spotting office chairs falling off the truck. And it seems to me like as this is happening just constantly, continuously, labeling, catching, using the fleet to pull the footage, the data, to train the networks, it makes more sense in terms of how improvement is going to be compounding, because the ability for the network to be able to train or to pull data that's relevant is growing, because now you have garages, and then you can have bicycles coming out of garages, or you have office chairs falling out of chairs, but you can have different things, a bookcase falling off a chair, or different things. So all of these cases start to grow, but your ability to, and you get better at recognizing, but also the ability to pull more and more data grows, because you're recognizing more and more things on the road everywhere. So
and that one of the questions that came up, which is actually a really good question, is like, how do you deal with the March of Nines? Because essentially, when we start getting really out in the weeds and we're trying to deal with really rare phenomena, like, how do you deal with that kind of stuff? In order to recognize a chair falling off a truck, first you have to know the chair part, and then you have to know the truck part. You have to know I'm on a road. You might have to know it's not sitting on the ground. It's not at the side of the road. I mean, there's all these things you have to understand before you can get to the chair falling off the truck thing. But the thing is, once you have this is a truck, and we're in this is a thing that shouldn't be happening. Once you know enough about the way things should be, you can start specifically looking for things that shouldn't be the way that they are. So as the network gets better, your ability to find edge cases rapidly expands. It's true that the edge cases are almost an unlimited universe of edge cases, right? But humans in the real world, they can sense edge cases that they've never seen before. I can be driving, I can not know what a tsunami is or a flood. And if I'm driving down a road and I see a lot of water, I know it's not supposed to be that way, and I can stop. The more stuff you know, the easier it is to detect the things that don't fit. And so your lever on dealing with the edge cases actually expands. It doesn't ever converge. Like, you never get to a point where you perfectly understand every edge case. But as the edge cases get harder and harder to detect, if your network is good and you're training it right, the network's ability to detect the edge cases simultaneously gets more and more powerful. So you can continue making progress on making the network better, even as the edge cases get really weird and out there.
Yeah. So this is, I think we're getting to kind of like the essence of how Tesla is going to solve, autonomous driving, is this continuous improvement that just compounds over time as their, data and ability to train their network grows. I want to take an example of, let's say, let's look at kind of interventions, how they're used, in combination with maybe pulling data. So let's take an example of, let's say, speed bumps. There was this one footage on Full Self-Driving on Twitter where the Full Self-Driving beta didn't catch the speed bump and just kind of went over very fast. Okay, so let's say in this situation, the driver intervenes, presses the brake or something, and it disengages. So now Tesla knows there's a disengagement. It goes into, and it's pushed out to them, and so they're able to pull that footage of the disengagement, let's say 15, 20 seconds before and after or something. And they pull that, and they look at that and they go, oh man, the neural net didn't pick up that this was a speed bump. And so then they can label that. They go, okay, this is a speed bump. But now they don't have enough data to truly, train the neural net that this is a speed bump. So now they push out a request to all their cars saying, hey, look for speed bumps. And then basically the network of cars will bring back images. And going off of what you're saying, depends how much data you want. You could make it more accurate or less accurate, the request. But you bring back, let's say, a bunch of data, and let's say a certain percent are real speed bumps. You have human labelers, labeled all these things as speed bumps. In the future with Dojo, you could, let's say structure through motion, you can have them just, like label the speed bump in a structure through motion thing, and all of the frames would be, have that labeled as a speed bump. But for now, let's say they do human labeling for the speed bump on certain frames, and then let's say they're able to get 100 speed bumps back, correctly labeled by human labelers. They put it back into the training system. The neural net gets trained where it reweights, the weightings between certain nodes to basically make the results where they can now, conclude that these are most probably speed bumps. And so now that they push out an update, let's say to these full self-driving beta cars, and now when the full self-driving beta cars go over or approach a speed bump, more likely than not, or the ability for the neural net to pick up the speed bump is greatly improved. So then people are like, whoa, I didn't know, like just a couple of weeks ago, I ran over the speed bump, and now, I'm stopping before the speed bump. I mean, is that generally how the system is kind of working?
Yeah, I mean, that is one mechanism that's going on. You can also do a thing with your interventions, where you push triggers out to the car and say, if there's an intervention, look for these things. And if you see one of them, send it to me. So you can send like the speed bump thing, it's not speed bump, not speed bump. It's, there's a dark patch on the road. What's the probability that it's a speed bump? The car thinks. And you tell the control system for the car is like, well, if it's less than 50% probability, don't stop. Or, if it's 90%, stop. Or, it has some kind of threshold. So one thing that you can do right away, you don't even have to retrain the network, is if you're looking at these things and you've told the car, stop if it's, 98% chance of a speed bump, because maybe otherwise you're afraid it would be stopping all the time for shadows and random things on the road. And, people drive it for a little while and you find out that the right threshold is really 95%. It's not 98%. So you just push that one number out to the car and all of a sudden the car behavior changes. And it's because you've learned what the right threshold is for taking that action is. So I think a lot of these immediate improvements that we're seeing in the FSD cars, they're probably along those lines because they haven't really had the time. I mean, the data engine, it's a 1 or 2 week cycle for them to push out requests for tags, get the data back, give them to the labelers. The labelers go through, curate the set, label it properly, stick it in, retrain the network, verify that there's no big bad bugs in the network, and then push it back to the cars. It's like a 2 week loop, right? But a thing that you can do right away is you can look and say, well, I had 57 interventions here, and all of them had the speed bump probability between 95 and 98%. We didn't stop. If we had set it to 98, it would be. And then you can look at, you can just bring that number down a little bit. And then you look to see how many places you were slowing down where people press the accelerator instead, right? Because they're telling you, oh, you saw a speed bump and it's not there. And you feed that back into the car also. Mm-hmm. And it can be, it's probably more than just speed bump versus not speed bump, right? They probably have more categories of stuff going in there. So you can slice that problem a little bit more finely too, because there's speed bumps, it's like, it's a yellow stripe on the road. And there are other speed bumps where it's a shadow, mm-hmm. and you might have different categories for those.
Got it. So, it's interesting. So you're saying that these certain variables or settings that, for example, the percent, let's say 95%, or the threshold that it requires for them to, let's say, stop at a speed bump, that stuff you think can be pushed out without a big firmware update, you're saying, basically through push type of software setting updates, right?
So what I understand has been seen from people who have watched these things go back and forth between Tesla and the cars is that neural network weight updates, they only happen with relatively big pushes. Now, so the packages that get seen, the neural networks are big. They're large files and they're highly interdependent with a bunch of other stuff. And the packages that get pushed out to the car that update the neural networks, as far as I know, they only happen with a pretty big push, which is the kind where, the car has to go to sleep and wake back up and it takes 30 minutes to install it or whatever the deal is. There could be exceptions to that. Like it's possible, some of the neural networks, there's a bunch of neural networks in the thing. And it could be that you have a small neural network, say the windshield wiper network. This is something that they struggled with for a really long time. And for like a year, the neural network, it kept getting bigger and smaller, and it was combined with this and that, and it just moved all over the place as they were trying to figure out like how to get the windshield wipers to accurately detect rain, right? but it's a relatively low risk neural network. Like you could, and there were times where it was pretty small. So it's conceivable, although as far as I know, nobody ever saw this happen, that Tesla could have just pushed out a new neural, windshield wiper network if they really wanted to try something. Nobody saw that happen, but it's not beyond the realm of possibility. On the other hand, there are these smaller sort of hyperparameter files, right? And it looks like they do get updated, right? So you could have a file that's got a bunch of these percentages, like slow down if the curve is tighter than this, or stop if with this probability if you see this. And the windshield wiper thing, it was producing a rain probability. Like it had these, it changed a bunch of times. So for a while, it had these different categories of rain, like is it drizzling, is it or whatever, and it would give you a probability in each of those categories. And then the software that would turn on the windshield wipers, it would look at those probabilities and make a decision. And you could imagine that those are numbers that you could move around, right?
Mm-hmm. Definitely. This is great. I think it's definitely helping me to understand. I think it's going to help others as well. I want to ask some questions on this whole idea of the perception engine for autopilot or full self-driving versus like the planning kind of section. So I mean, from my understanding, you have this perception type of system where you're trying to understand the world, right? And what objects are going around, moving around, basically interpreting what's happening. But then there's another type of set of challenges, which is how do you navigate through that world? What decisions do you make? How fast do you go? When do you turn? How do you turn, etc. And it seems like what Tesla has this stuff in a separate type of system of planning system where it's just determining how to plan. And some people have asked me on Twitter, is this planning system mostly like hand coded, things, and is there use of neural nets in terms of actually making the planning more automated, or the improvements to the planning more automated? Or do you foresee kind of this planning system still being kind of hand code driven, into the future?
Yeah, so people talk about these systems as like planning, perception, and action, right? And kind of got these three big categories of stuff. And the big challenge has been having accurate perception up until now. So that's the there are things in planning which are really amenable to a neural network doing them, and there are other things that are less amenable. And all of these systems have, I call them a harness that it runs in. You have this, all of them have handwritten code that looks for really stupid stuff that's almost certainly a mistake, and it prevents bad outcomes by looking at that. The harness is mainly there to catch bugs, because neural networks can have bugs too, right? I mean, you can have something which is just like this really weird output that you get. It's very rare, but it does happen. And building the harness is relatively straightforward. You kind of do it once and you don't have to do it again. And everybody who builds robotic systems in the real world, they have a harness around this thing that looks for, and you can look at, there are lots of different ways you can examine this, the output of these neural networks and these planning systems to decide if it makes sense or not. And the harness will intervene and prevent that. Now, it used to be like, especially on AP1 and early AP2, you would see the harness kick in all the time. Like you could see all these hard thresholds, or like it would be doing a thing and then the harness would kick in, right? Like one of them, AP2 for a really long time, it had a harness around how tight you could turn on a freeway, right? Because one of the failure modes they had is the wheel deciding to turn too tight for how fast you were going on the road, right? And so for a long time, the car's main failure mode on highways was slowly drifting out of its lane. You'd be driving, maybe the speed limit's 65, but the traffic's going 75, so you're going 75, and you come on a relatively tight turn, and you'd see the car just slowly drift out of the lane. You're like, what is going on with that? I mean, you could look at the display, and the display lines, it clearly knew where the lane was, because you could see it drifting around the lane. Why wouldn't it stay in the lane? Well, the reason is they had a hard setting that said, at this speed, you cannot turn the wheel harder than this, right? Because that was a safety harness. And the harness kicking in is what prevented the car from getting in the lane, because you just happened to be on a road where how fast you were going too fast for how fast the harness would let you turn in that kind of situation. And for a while they needed that, because the accuracy, the curve prediction accuracy wasn't good enough that you could avoid occasional really bad situations, right? like, there's this hill cresting problem they used to have where you for a long time, the way that it understood where it was on the road was it looked for lane lines. Like in the beginning, lane lines were really important. They're very unimportant now, especially with FSD. Just human beings treat a lane line as if it's just suggestion, because you can cross. If it makes sense, you cross a lane line, right? If it's safer to do that or quicker, you just cross a lane line. But autopilot, for a long time, lane lines were God. They were like concrete boundaries, and like it wouldn't cross one of those unless the harness kicked in and said that it had to, right? And that was the one situation that it would do. But so you had this hill cresting problem where like you're driving down a road and the road's kind of going up and down, right? And it's got a little wobble back and forth to it. And occasionally you get a thing where you're kind of on a curve, and as you're cresting a curve, there's, the car can't see the lane lines over the curve, so it doesn't know where the lane goes, right? Now, if you're on a completely dead straight road and it crests, the car would guess, oh, it's probably straight on the other side, right? But if you're curving, when it gets to the top, it's like, because a lot of times the curve changes right after you crest the hill or goes straight. Sometimes the car would freak out at the crest, right? Like because the lane line just disappears and it's got no horizon for the road or whatnot. And then, just as you're cresting the road, it can kind of see some marks on the far side that are giving an idea that the lane goes this way, the lane goes that way. And suddenly it would want to turn the wheel right at the crest of the hill. This was a really common failure mode. And if you drove on those kinds of roads very often, you would see it all the time. You could predict it as a driver. You're just like, oh, it's going to happen right here. You'd be coming up and the wheel would suddenly jerk. And the harness was a way of making sure that those jerks were never bad enough that they would cause an accident, right? So you have these harnesses in there. So nothing is completely without hand code, right? They're going to be these safety harnesses all throughout the system that look for stuff. Perception didn't used to all be neural networks. It seems like perception is almost all neural networks now. The camera networks in FSD, they now have radar getting fed into them, which they didn't used to. It used to be that neural networks would process the camera, they had a separate neural network for radar someplace, and then there were some other networks that would combine that and some heuristic code that would combine it. But now they're starting to bring more and more of the sensors together at an earlier phase of the thing. And those networks, as the system gets developed, they extend farther and farther up into in perception. I would guess at this point, there's a lot of stuff I can't see. The stuff I can see is neural networks. Like the stuff that I get access to is just, that's what we go looking for. That's what the other guys give me. And that's what I get to process. So I can look at it and see what's in the neural networks, but I have to guess about what's not in the neural networks, which I do by observing how the system behaves and, just sort of common sense and that kind of stuff. The neural networks, they're accumulating more planning like features in them, but planning isn't entirely neural network. And to some extent, like, we're not in any reasonable time going to get to a point where you stick the Google map in the neural network and then the neural network decides, how you get. There's going to be heuristic stuff for route planning and all that kind of stuff. And it has to interface to some level of the planning module. What lane do I need to be in when I cross this intersection? Depends a lot on where you want to go. And there's going to be a heuristic mapping module that's going to decide that kind of stuff. And it's going to be part of that equation for a really long time. Mm-hmm. But the whole decision about like, how fast do I move over to the left lane so that I can take this left, or is that not safe? And should I just go through the light and take the next left and come back? Those trade-off kinds of decisions are eventually going to be almost all in the neural network, but they're not now. So planning, there's a decent amount of very neural networky stuff in there that I think is already being done by the network. There's a huge amount of stuff that's not neural network now, and probably isn't going to be in any reasonable amount of time. And that boundary is constantly shifting. As a neural network can do and more of it, they hand more of it to the neural network. And then what they had before becomes a bigger part of the safety harness, right? It becomes a stop back measure to make sure that the neural network is behaving itself. Does that answer your question?
Yeah, that makes sense. So in your opinion, the perception, the problem is the big problem. I mean, is the planning, it would be more secondary, the challenges that faces over time?
So all of these systems have aspects which are either better or poorly suited to heuristic code versus handwritten code versus what neural networks do. And it's a moving target, right? The heuristic stuff has been around for a long time, and robotics is a mature field. Like, there are a lot of well understood techniques for dealing with these things at heuristics, and we have a pretty good understanding of the bound of what those things can do. So a good thing to start out with is you build it that way. And then as the neural network's abilities in that space overcome the heuristics, then you hand that over to the neural network. And then once again, the heuristic becomes part of the safety harness for the neural network at that point. And one of the things that kind of surprised me, I wasn't expecting when I started looking at Tesla's neural networks that the insight I was going to get was how their development process worked, right? Or how fast they were doing stuff. But after looking at them for a while, like that has been one of the things that sometimes it's kind of frustrating. If you're looking at, if you take apart an integrated circuit and you're looking at it and you don't know what it's for and you're trying to figure it out looking at it, there's stuff you get, there's stuff that you don't get, and there's all kinds of mistakes you make when you make guesses. I'm sure there are a lot of mistakes I make in looking at Tesla's code and trying to understand what it's going to do. But one of the things, if you look at lots of generations of chips, you end up getting a lot of insight about what's going on by like, what did they change? What changed and how fast did it change? And like, what was the car doing, when I was driving it, when that changed, as you watch the stuff evolve over time. So in a weird way, I've got more insight into what they're doing than how it works. Even though when I was looking at this, I was only interested in how it worked, because I didn't expect to be able to get any insight into what they were actually doing. But now Karpathy's been talking about it. And because of the history of how these things change, like the thing with the windshield wipers, right? I thought it was just comical how much the windshield wipers changed over time. Because clearly it's not a super important, it's not nearly as important as all the other safety features. You've got to be able to see out the windows, there's that aspect to it. But, if the wipers are a little fast. But the thing is, all the time that I saw the windshield wiper changing, I saw all these people on social media constantly, complaining that the windshield wipers didn't work. And it gave me the impression, well, they really do care. If people say, oh, the thing that turns the high beams on is blinding the people coming on, then you start seeing rapid evolution in those features inside the neural networks. And it's an interesting insight into the mind of the company, right?
Yeah, definitely. Quick question. Do you have, are you time constrained at all, or can you go on for?
I can keep going for a while. I don't have a stop today.
Okay, cool. You had this idea, actually, I appreciate the conversation a lot. I feel like we could do maybe, I don't know if you're open to it, but maybe in the future we could do some type of live stream where we just go on for just for 5 or 6 hours or
I have
7.
To think about that.
5 or 6 or 7
I
hours.
think I might be too intimidated trying to talk to people live.
But we would just do something, the same thing. We just talk just for that time. But I feel like I could talk with you for 10 hours straight. And I still would,
flattered.
Yeah, I still would have stuff to talk about. I want to talk about, moving on to kind of more of the business case or the competition regarding autonomous driving. It seems like, Tesla is definitely in the forefront of autonomous driving, especially with this more, passive optical generalized solution approach. How do you see all this working out? So let's say, look out 5 years down the road. Do you see Tesla rolling out their Robotaxi network where people can go in the car without, a supervised driver, just, the car drives the people, by itself. Do you see that happening? When do you see that happening? And is Tesla going to be able to roll out that type of network at a pretty fast pace, or will they meet a lot of regulatory challenges along the way? Are there going to be other companies that, try to copy and follow Tesla's kind of lead? And how many years behind do you think they are in terms of releasing their own Robotaxi network, as Tesla gets theirs up and running? So kind of what's your take on kind of those type of questions?
So when I think about this stuff, an easy trap to fall into is forgetting that all these predictions, everything you're thinking about, it's a moving target, all this stuff, right? In the long run, autonomy is going to be ubiquitous. All the cars are going to have it. Taxis are going to cost 50 cents a mile or something like that. And they're just going to be completely ubiquitous and nobody will drive cars. Most places you won't even be allowed to drive a car, right? That's the end game that we go to. They're all electric. They're all autonomous. People still have private cars, right? But it's not what most people do most of the time when they want to go someplace. That's where we end up. right now, recently, when I've been trying to think about how this unfolds, I sort of think of, we kind of have these 3 or 4 phases that FSD evolves in. And Tesla's FSD isn't the only competitor in the space, right? There are other, Cruise and Waymo are both doing very different things. And Mobileye is actually doing a different kind of thing, which is in some ways similar to what Tesla is doing, but their market structure and all that stuff is going to be quite different. But just thinking about Tesla, so you have this era where there's no FSD. Let's call that phase 0. And then you have this era where there's FSD, but it really needs supervision. Well, let's call that like phase 1 or whatever. Okay. So there's 2 more phases after that are interesting to consider from a commercial standpoint. One of them is where there's FSD cars, but the market price is set by human drivers, whether it's taxis or Uber or Lyft or whatnot, because automated cars are too small a chunk of the overall market to set the going rate. Then there's this end game where, because taking the driver out of the car just makes the service a lot less expensive, especially when you're talking about electric vehicles, because electric vehicles are going to be 20 or 30 cents a mile to drive. If you look at the cost of tires, the cost of maintenance, it's really inexpensive to operate an electric vehicle compared to another thing, especially when you take the driver out, right? So in phase 2, FSD taxis are operating in a world where they have an umbrella price, which is set by what human drivers cost, right? And so I think ARC estimates that that's like $4 a mile, $4 a mile, right? So then there's this long-term game that you get into where taxis are super ubiquitous. There's 4 or 5 big players, right? And it's been commoditized. So in the commoditized world, you could have an oligopoly, but if we assume that it's actually a competitive world, then, what you see is, taxis cost, 50 cents a mile, and the margins are 20 cents a mile or something like that, which is shared between, the various entities that help provide that service. But we have this middle window, which is going to persist for a while. It's going to persist from the time that FSD is good enough that at least some jurisdictions are allowing it to be used. And it's going to continue until they're basically ubiquitous. FSD or other robotaxi services are ubiquitous enough that that the ceiling price is set by them. So right now, the cost of providing this service, bare bones, right, is like 20, 30 cents a mile. There maybe 50 cents a mile, if you throw in all kinds of other stuff and then you assume, that it's complicated in the beginning and stuff like that, right? But the thing is, the going rate for these services is $4 a mile. Maybe it's $3 a mile in competitive markets or whatnot. So there's like $2.50 a mile of umbrella being provided by the cost of human-driven cars that is all of a sudden, that's essentially pure profit to the FSD robotaxi fleet, right? And you could imagine that $2.50 getting allocated in various kinds of ways, like, Tesla gets a chunk, whoever owns the vehicle gets a chunk, assuming it's not Tesla that gets a chunk. Some of it you give to the customer as like a discount against what a human driver costs, maybe because your network's not as big and you're trying to build the scale or whatever the deal is. But it's $2.50 a mile. It's huge, right? So for as long as human beings are setting the umbrella price, the difference between that $2.50, that's the value of autopilot in that car, right, over the value of the car itself. So maybe, a Model 3 is $40,000, right? And we ask the question, what's the value of autopilot? That, which is a little different from what's the price, right? Because Tesla's going to set a price, I would argue. Like their mission is not, let's make as much money as we can this quarter or this year or in the next 5 years. Their mission, their stated mission, is accelerating the transition to sustainable transportation. And if you believe that, and I kind of do, because unlike a lot of companies, they tell their investors and their customers the same thing, right? And they both tell them, this is our mission, right? You might not make money next quarter. They say that. And it's been consistent with their actions. So if we take that at face value and we assume that that's what they're going to do, right? Then during this transition period, they're going to operate according to whatever strategy minimizes the number of miles that people put into fossil fuel vehicles, right? Which is pretty much everything right now. So basically, the more miles you can get people in Tesla, to a first approximation, you can say every single one of those miles is a mile that they didn't drive in their Ford F-150 or in a New York, gas-powered taxi or whatever the deal is. In that sense, a robotaxi that's driving 100,000 miles is, 10 times as valuable to Tesla's mission as a privately owned vehicle that's driving 10,000 miles a year is, right? So now this is an interim thing, in the long run, there are plenty of private vehicles and plenty of taxis. But Tesla's going to have this long period of time where they're production limited. Like, they haven't got enough factories and their factories can't crank out enough cars to meet all of the world's demand. So I would argue that Tesla, in that window of time, they have a strong incentive to make the use of their vehicles as robotaxis as attractive as possible. And one way that they can do that is they can give other players an economic incentive to buy those vehicles and operate them, or they themselves can operate them as doing it. I mean, it's much more capital intensive if Tesla tries to own all the vehicles. But look at the simple math, right? If the going rate is $3 a mile and it costs you 50 cents a mile to operate the thing, then you make $2.50 a mile on cars. Like, somebody gets the $2.50 between what the customer pays and what it costs to operate the vehicle, right? And it's super easy to generate 100,000 miles a year of trips in one of these taxis. I mean, that's what rideshare vehicles can do in popular markets, right? So that's $250,000 a year, which is significantly more than the value of an individual car, right? And in fact, if Tesla's taking any significant chunk of that, say they're taking 50,000, say they're taking 20% of that, right? And that's all that they take in. You give some of it to the customer in terms of a discounted rate, and you give a big chunk of it to whoever the vehicle owner is, right? Tesla still has a really strong incentive to incentivize people to use the cars that way, because they made $40K selling the vehicle, and they're going to make $50K a year for as long as the price umbrella is being driven by human-driven cars, which is going to be years at least, right? So when I look at that, I think that Tesla's got a really strong incentive to make the autonomous taxi thing as attractive as possible. And as long as they're production limited, they're going to try to push vehicles in that way. At the same time, it's the private vehicle market that bootstrapped them into the position that they're in right now. They're not going to abandon. I have a friend who is betting that Tesla would just go all fleet because that's easier. I actually think that that's strategically not the right thing to do. Because, transportation as a service has a stack. Somebody makes the car. There's somebody who operates the car. There are people who insure the car, right? One of the natural states of it's highly geographic, right? So, the market in China is completely separate from the market in Denmark, right? And even New York and California are pretty isolated from one another. They have a lot of stuff in common, but the assets don't trivially move back and forth between New York and Los Angeles, right? So they can kind of operate independently. Transportation has always had these kind of local oligopolies. Because there's an efficiency to scale, actors tend to go to scale. Once you get to a certain amount of scale, you start to get pricing power. Once you start to get pricing power, you tend to, essentially try to extract more from the customer because you can. Because in the short run, at the margin, that's kind of the more profitable way to do that. But the more effective you are in doing, the more effective the provider is in setting the price, the less penetration the product ultimately gets, because there will be some marginal number of customers that don't use the service because it costs too much for them, right? If Tesla wants to get the most cars out there and getting the most to drive the most miles, their strategy has to be aligned with trying to get the end price down as far as possible as long as you can keep all your cars busy, right? Once if all the cars are busy, there's not much point in dropping the price below that, right? But I think that price is relatively low. And for them to basically facilitate, say, a New York oligopoly of 4 or 5 companies that own all the Tesla taxis, and a Seattle oligopoly that owns all the Seattle taxis, to the extent that becomes the normal business model, from Tesla's perspective, assume if you can't keep all the cars busy, which is a caveat, right? That becomes a limiter on reducing the number of fossil fuel vehicle miles that are out there, to the extent that they're the primary competition. So Tesla doing an approach where instead of basically trying to pick, big players in markets where they can sell a lot of vehicles and they have relatively little paperwork. The other approach is basically what they've described as the Tesla network, which the more I thought about it, the more it occurred to me that in the long run, strategically, this is really the right way for them to go to further their mission. Because if in every market you have 100 small players that have 5 or 10 cars, right, people are going to compete on price and the quality of service that they can provide. They're not going to compete on trying to get pricing power so that they can dictate what the margins are. If Tesla's the only player, the only consolidated player in the entire stack, and everybody else is very small entities, right? Tesla can focus on basically providing the infrastructure for there to be a market in every jurisdiction that operates these cars, so that the price is basically set. It's the compromise between what the riders are willing to pay in order to ride lots of miles and what the providers, want to charge in order to have a reasonable livelihood. And if you think about an individual being able to buy, say you're a small business owner and you're going to go into the Tesla taxi business and you got 10 cars, right? If you look at the amount of money that's on the table, like an individual car is literally generating in today's world where the going price is $3 a mile or whatnot, like $250,000 of value a year that you're going to share with Tesla and your customers per car that you have. And that the cash outlay to get at least the hardware of the car is $40,000. That's a pretty attractive business. A lot of people, there are plenty of small business owners that would love to get into that thing. And if Tesla goes that route, they build a constituency of small business owners who have a strong interest in the strategy succeeding and who are competing on price and the quality of the service that they provide, essentially maximizing the leverage that the market provides in terms of like finding the right price point where everybody gets a ride and they get it at the best possible price, right? Getting the most people out of fossil fuel vehicles. So the more I thought about that, the more I like that vision. I like that structure and the story that goes behind it. I could see other approaches depending on how it works out when they go. But, we've got Uber and we have Lyft. Right, we've got these examples that give us some understanding of how that dynamic works between the market. And I would say, just looking at them, that it suggests that it's a viable strategy. That the Tesla network is something that really could work. And the infrastructure of writing the software and having the back-end servers and adding all the features. Like if you're a little fleet owner, you want to be able to specify, I want my cars to operate in this jurisdiction and not that jurisdiction. And this is the price I want to charge. And, this is the parking lot I want them to go to. There's a lot of features you have to add to the software in order to do that. But that all seems completely within Tesla's software development capability and their ability to run a backend. Like I can see them building that and operating it and trying to take advantage of that. So the question at our last conversation was, you asked me, it was like, would Tesla really charge $100,000 for that software feature? And that's a really interesting question because you can imagine different strategies going into this thing, right? I mean, one thing that you could imagine is Tesla they have a strong incentive to get for the vehicles to be out there and well, first of all, they want those vehicles driving around, displacing fossil fuel miles, right? But how do they maximize revenue? And at the same time, how do they maximize the buy-in that they get both from the riders and from the fleet owners that they're enabling with the system? And that's an interesting juggling act. Like you can imagine a lot of the fleet owners might be people where, they can't go out and buy 10 of these cars on their own. You could imagine them starting with one car and then using it to buy a second or a third one. You could imagine a situation where Tesla says, we're going to finance it. Like, we'll give you autopilot for this price. For this price, you pay it off by essentially giving us an extra cut for however many years that it takes to do that. It's a lot more reasonable for Tesla to finance a software because they have no upfront cost for it. Financing hardware means you got to borrow money from a bank or something like that. But if Tesla puts out a product which is just software that has no marginal cost for them, and then to create whatever incentives that are necessary to get small fleet owners to want to commit to this business, they can offer whatever incentives that they need to at the software end, right? Whatever maximizes their ability to extract value, because they have an interest in extracting, a reasonable amount of value from this also, because they feed that back into their ability to produce actual physical vehicles, and they ramp that curve also. So so I could see it being $100,000 feature if the financing and the incentive structure for the purchasers makes sense, because it's clearly worth, in fact, it's worth, like, in that window of time where miles continue to cost like $3 or something like that, where that's the going rate for miles, the net present value of autopilot, if you assume that that's going to continue for a while, that's like $500,000. It's an astoundingly huge figure, right? So do I think Tesla will end up extracting $100,000 of value out of that? Oh yeah, I really do think they will in the front, right? But then, the price is a moving target. Like, that window is going to close, and the end game for that is, all of the autopilot fleets are operating at 20% margin, like any reasonable business.
Sure. Like, I think the big question would be, okay, so you describe these 4 phases. Let's say phase 0, no autopilot. Phase 1, you have autopilot or full self-driving. Is it beta?
Supervised by people.
Okay, then phase 2 is unsupervised, but Tesla has this big lead. And then phase 3 is this commoditized autonomous driving?
Yeah, so the key thing in phase 2, right, is that the price of service is still determined in the market by human-driven cars, because autonomous cars haven't hit enough penetration that basically it's driven, that the price has had to come down. Sure. Because it's super competitive.
Sure.
So that could be not just Tesla, it could be, maybe Mobileye's got a fleet, and, Cruise and Waymo are operating fleets too. I mean, everybody, and there will be trade-offs, I mean, the transport market is it's interesting in that, you have limousines, even Lyft and Uber, they all have 3-4 levels of service, right? And prices vary depending on geography and stuff. So I feel like it's inappropriate to try to think of this as a one-size-fits-all, and I need to come up with a solution that works in, the boroughs in New York and also works in rural Iowa, right? Mm-hmm. The reality is that those markets are reasonably separated.
It seems to me that this phase 2, where you have this combination where the human driver networks, Uber, Lyft, are predominant, and you have these autonomous networks that are up and coming. It seems like, in some ways, that I guess there's a few questions. One is, how long will this phase be? Right? It makes a big difference if it's just a few years versus 10 years. Because if it's 10 years, then these new autonomous networks, especially the leading one, or ones, will have an immense advantage, because, I don't know, it's, in a way, it's like the less competition. For example, if Tesla is ahead and it takes 10 years for people to catch up, then they can extract that extra value for an extremely long time. But if this phase 2 is actually short, if it's only 2 years, and before everything switches over to autonomous taxis, then in phase 3, then Tesla won't have a lot of time to extract that, extra value, right, in that phase. And so,
but I mean, you can kind of look at this and bound that, right? It's not going to be 2 years.
Okay. Well, it's going to be,
that is way too short.
Okay. Well, that's the thing. It might not be 10 years though, right? I mean, and there's obviously,
10 years would be on the long side.
Yeah. It's obviously going to be
the difficulty of doing this is coming down, right? Mm-hmm. Tesla's up in front, but the follower, the second person to do autonomous driving the way Tesla does, and there will be other competitors that don't do it Tesla's way also, right? Tesla's got a significant long-term advantage against Waymo and Cruise type approaches in that their platform is a lot less expensive and it's a lot more general, right? So there will be markets they can go after because they're either the ridership is price sensitive enough, or because the ridership is infrequent enough that it doesn't make sense to HD map, rural Iowa, or, there will be places where the cost advantages of Tesla's approach are really significant. So even if Waymo is super successful in certain areas, and even if Cruise is super successful and competitive in some areas, Tesla has a significant advantage once they're actually able to operate that allows them to operate even if the other two are successful. So I think the situation where they don't succeed, because of competition is I pretty much discount that. I looked at ARC's model recently. They have a financial model, and they only gave Tesla a 30% chance of success, right? I mean, that was the probability they put in their autopilot model. And it was a couple of years ago, and things have changed a lot. They're redoing their model, and I suspect you're going to see that number is going to increase a lot. But I look at that and I'm like, God, I have a really hard time coming up with scenarios where it doesn't work. I mean, as somebody on the tech end, I look at the tech, and I'm a deep learning tech guy too. I'm not a robotics tech guy, but I look at this and I say, the tech's going to work. It's just a matter of time. Maybe it's delayed a couple of years, but it's definitely going to work, right? And then I look at the scenarios. Well, what is the scenario where they get cut off because Uber owns the market, right? And they don't get access. Like I've heard this argument, and none of those actually work, as far as I can tell, right? The scenario in which Tesla gets locked out of the market and doesn't have a competitive advantage in a big enough market that they can continue to grow. That just seems remotely unlikely to me.
I mean, like the way I'm looking at it is like Tesla, it's definitely one of the most exciting parts of, I think, Tesla's business future is this whole autonomous driving, including Robotaxi network. I mean, for me, it's like, Tesla's in the lead. Unless they majorly screw up, it looks like they're going to be not just first to market, but, the dominant player in the foreseeable future with...
Well, I mean, arguably, first to market is Waymo, right? And I wouldn't be surprised if Cruise gets to market too. That is in terms of having a Robotaxi network. Now, it's not profitable. It's not at very much scale. That's true. Right? It's not a real business.
Exactly.
But they are in the market.
Yeah. If I would maybe define the market or the term as a generalized solution that would take out Uber and Lyft, overall. I see, Tesla's in the lead. They're destined, unless majorly messing up to dominate that market. The question though is how long will it take before other people start to catch up, right? Because if it takes like 5 or 10 years for people to catch up and to create competing autonomous network, that's 5 or 10 years of immense amount of profit where Tesla can extract, more profit, share it obviously with the consumer and, the Tesla owner, but still that's an immense amount of period. But if that period is only, let's say 2 to 3 years or so, then that changes how much value, right, Tesla can extract from that, I guess, big gap, right? I mean,
and the reality is it's a curve, right? It's not a funk.
Yeah.
And the shape of that curve is like, I mean, the US is going to have that curve, and China's going to have that curve, and Europe's going to have that curve, and India's going to have that curve, right? Indonesia is going to have that curve. These are going to happen at different times, and they're in radically different markets of different sizes. The area under all those curves is trillions of dollars, right? I mean, starting out, there's like $3 of value, in every mile that gets driven. You give one to the consumer, you give one to the fleet operator, and Tesla takes one. And yeah, that's a lot of money. It adds up to a huge amount of money. Realistically, there's just no way this window isn't, at least 2 years long.
Sure.
And 10 years is stretching it. Like by 10 years, you can imagine that in the best markets that are the most low hanging fruit and that you can charge the most margin, because, you don't get $3 a margin in Indonesia, right? Or India, you get that in Manhattan, and you get it in LA and San Francisco and places like that. But yeah, it's 10 years, right? Yeah. It's not 20 years. Sure. It's 10 years. It's not. And by the time you get to 10 years, there's a significant taper on the amount of value you can get. Because how many cars is Tesla going to have shipped by 10 years from now, right? It's enough cars that if it's a really attractive model, you can imagine, making it essentially the presence of automated Teslas in markets like the really good markets like, San Francisco and Seattle and Los Angeles and New York, pushing down those prices already, having a big impact on that.
So I want to take kind of a little bit of a counterpoint here for discussion purposes. So I look at somewhat this like transition period, I guess the phase 2 moving to phase 3. I look at it as like very blended in a sense where it's not like obviously like a, cutoff thing where it's very complicated, as you say, geographically, but also in terms of like what happens in terms of getting to that tipping point where there is more autonomous cars than there are human driven, let's say taxis. And I think it's in some ways like that transition period, because it's so blended and it requires regulatory approval, a lot of things, it could be in a way first I don't see the switch coming on where within a year you have like all 50 metro areas or something, or 50 metro areas covered with Teslas, right? I mean, it's going to happen over time. And in some ways, I feel like it could be an advantage for competitors, because once Tesla, let's say, gets their first, let's say, regulatory approval, they roll out in one local area, competitors are going to be able to see that, and Tesla won't be able to move maybe as fast as they want to move on their own if there wasn't a regulatory body approval at hand. And so that's going to slow down the process, where it's going to take several years to get regulatory approval in different localities, but also in different countries. And during that time, it's kind of like what Google did with the iPhone is, Eric Schmidt being on the Apple board kind of gives them a heads up, and they see the iPhone and they're like, oh my gosh, this thing is just going to take over everything. We need to act immediately before Apple gets a monopoly and kicks us out of, the phone. And so you have emergency meetings at Google saying, hey, we need to, come up with a competing operating system, etc. And so in a similar way, I feel like once it dawns on people that what Tesla is doing is for real, and this isn't, they can't be stopped. Like this is going to happen. And, the Robotaxi fleet starts to get rolled out, you're going to have some emergency meetings and emergency type of measures happening where it's going to be a catalyst for major change. So whatever Tesla does to get the Robotaxi going, you're going to see a response from big players. And let's say Google says, hey, we don't want to get kicked out of the car. We think the car is going to be, a huge thing, and we don't want to just have to be at the mercy of a monopoly of a Tesla operating system in the car. And so Google says, okay, we're gonna buy, maybe they buy Mobileye off of Intel, or let's say they buy another type of company. Let's say they buy Comma.
Google can just develop it themselves.
Yeah,
right?
Yeah, that's true too. Or they buy Comma.ai, or they develop themselves, or basically they pivot, right? They say, okay, our Waymo division is not working, as well as it should. Let's put 1,000 engineers on this problem to do a neural net based approach, copy Tesla, poach a bunch of their employees, give them crazy stock options and incentives, and
that's totally going to happen.
Yeah, and
it's easier, right? The level of effort that it took Tesla to do this at a particular point in time is going to be a lot greater than somebody who starts 5 years later.
Exactly.
Right. Because
it's been done.
Tech is
exactly. Yeah. And then here's the kicker. Google comes in and says, we don't really need to make money off of the hardware or the software. We're going to make money off of ads through people just searching and watching YouTube in the car.
The service itself is super valuable. You can make money off of that.
You can. But let's say Google does this Android move where they say, hey, we're not going to make money off of this software, right? We're going to make money off of people. Google's motivation, let's say with Android, is not necessarily to monetize Android. It's to keep from being, destroyed on the smartphone ecosystem, right? They want people to continue to access Google services, right? The search and the YouTubes and the ads and everything. And that's how Google survives in a way. Like, in my opinion, Android was a defense move against, Apple's kind of domination of the pending domination of the smartphone industry. So in a similar way, if Google says, hey, we're okay with not making any money off of the actual hardware software, we're going to just ensure that we're kept in the car, that people are searching, watching YouTube and everything, like we're the operating system of the car. That's our goal. And if they do that, then they tell the OEMs, they say, hey, we're going to give you this software, everything we're developing, it's going to be open source, just like Android. You can put it in your cars and you can charge whatever amount you want to charge on it, and you don't have to, like, pay us. I mean, there could be some type of, similar to Android, fees and stuff, but it's basically the vast majority of the markup goes to the OEMs. So the OEMs, they look at this and they're like, what a deal. We get free autopilot, free autonomous driving software from the best of the best, Google here. And Google's not even taking a cut, and we're going to stick it in our car. We're going to charge $10,000 or $20,000 or whatever. And they're going to think it's the lifeline. It's the thing that the OEMs all have been looking for, an ability to survive.
This is
right, in this
George
stage.
Hotz's, Tesla is the iPhone. I mean, he thinks that they're going to be Android.
Which they're not. I mean, I think they have a fascinating idea or approach, but I don't think they're it in the sense of, if you look at who has the momentum or the people and the money to spend.
Sorry.
Oh, no problem. Okay. Yeah.
Still there?
Yeah, I'm still here. Can you? Okay. Yeah. So if you.
But I can't see you.
You can't see me. Okay.
Okay, we're back now.
Okay. Yeah. But yeah, if you look at like who has the money, the will, the people, the everything. I mean, in some ways, Google matches a lot of those things, and if they, in my opinion, like the likelihood of Google doing something like this, where they say, we're not going to get kicked out of the car, we're going to put 1,000 people on this, just like they did to Android, and give it open source, make it free, and just so they're just they'll monetize in other ways. And the OEMs, in my opinion, it's an offer they cannot refuse. Like every OEM in the world, in my opinion, will take that up on Google's offer, because there's nothing to lose, on that. They all take it up. I think within a few years. I mean, they're gonna just, and Google has their all their different parameters of where they need the cameras to be, etc. They'll have like even like the standardized. They'll have everything set up where it's just a plug and play where they can outfit their cars with the necessary hardware
Elon
and cameras.
Had this thing he said where the technology is going to be ubiquitous. It's not a defense. It's not a moat. Being first doesn't, because there are strategies like what you're talking about where competitors can come in, and there's no shortage of them. I mean, there are other players that can do this, and the bar to reproducing this technology is just coming down over time. I mean, there's going to be a lag because it's going to take a while to do all this stuff. Even if no matter when, if you start 10 years from now, it'll be a lot easier than it is today, right? Maybe it'll be a high school science project to develop a self-driving car in 10 years, right? But even so, there's a lag between when you do that and when you have your vehicles out in force and your competitive thing. But in the long run, the best outcome for the world is everybody's got this tech and it's all commodity priced, right? Because then, all the miles are electric vehicles, everybody's in a safe car, everybody has the transportation they need to do all the things in their life, right? That's the winning scenario.
Yeah. And so, I mean, like the way I look at it is this whole, that phase 2, like I think the more Tesla starts to show the proof of concept actually working, the more incentive it gives for the overall ecosystem to compete against them.
There's this thing about that. I agree. I think all your reasoning is a fine scenario that for how this stuff could work out, and I don't disagree that Google would have incentives like that, and but there's this very interesting thing that I couldn't believe how long it took the car industry to decide to do EVs. And they're still, I feel like the proof of concept is there. Like if you were paying attention, the proof of concept was done when the Model S was out there. Like you might've had questions about the business model, but the Model S showed that the tech was doable. The 3 came out, right? And it's a slam dunk. I mean, it's a winning tech. It's difficult for me to imagine that there are serious, reasonable engineers at places like General Motors and whatnot who really think that the internal combustion engine is like a good value proposition for customers at this point in time. And yet you really don't see the wholesale transition. Like, in other words, the inertia and the siloed thinking of that industry it went way beyond. And like, I used to work for the car. Like I saw people in that industry when I was in the electric car business. Our customers were big 3, and big European makers and whatnot. So I had some experience with them, and yet their ability to deny reality and not want to do the transition went way beyond what I thought. So I wonder if, to what extent is that also true in the transportation? Is it the case that Uber and Lyft and like all the taxi companies and, car manufacturers are gonna see the Tesla network being successful and they're gonna go, oh, we got to go do that or it's gonna run over us? Or are they gonna look at it and say, like they did with Tesla, oh, that's a flash in the pan. Nobody will want to use that.
Yeah.
Nobody's gonna trust those things, and we're just gonna keep doing what we want.
Yeah. Well, I think the automakers are very slow and they're not going to catch it. But that's why I think like the likes of Google or some company it's more existential, or at least they see. I think here's the thing. Here's my perspective is these automakers, they're not really motivated. Like their whole business model and mission is just to make some profit, return it to shareholders. They don't really have much bigger mission beyond that. And so for EVs, it doesn't make sense to them. They're like, they look at that and it just doesn't compute. It doesn't even enter their brain as something that they should do, because their mission isn't to make per se the best car or to grow per se. It's just to operate.
Existential threats are also something that they're 100 years old, the auto industry,
Mhm.
right? They're this huge, slow moving, industry with all of this history. I think it's hard if you've been in the industry for a long time to really entertain the notion that, yeah, it's all going to end in a couple of years.
Yeah, yeah, exactly.
Whereas Google lives
Mhm.
in a world where those kinds of disruptions happen. I
Yeah,
mean, they went through a long period of time when there were alternate
yeah.
search platforms.
I mean, one of the things with Google is I think the big question mark to me is if they will look at the car as something like that is mandatory, that they need to really put like a big bet in, or will they like they did with Android, like because when they looked at iOS, I think they looked at it as it's existential for Google to not have Apple be a monopoly on the smartphone. The question for me with Google is if they will look at the car similarly, or if the leadership in Google is not, going to look at the car in the same way and will be slower. My hunch, though, right now, I'm leaning on that Google will make a big bet on the car, because like there was this. Have you seen the Volvo Polestar? There's yeah, there's this video out of, or several videos, but people kind of playing around with the UI for the Polestar,
Mhm.
and it seems like Android has it's not like the whole Android phone you connect to your phone and it's a complete like complete auto interface where you can
Mhm.
control like all of the controls. You can see your range, you can control like your temperature, you can see your batteries, you could control your charging. Actually, you can do almost basically everything that a Tesla UI can do actually with this Volvo Polestar UI, which is actually made by like Google. It's an Android extension. It's
Yeah.
basically for the car, which is
But they've been making that product for a while,
no actually
the Android for the cars.
no. So what they've done before is they've kind of made this so-called Android Auto, where you kind of like
Mhm.
project your Android phone onto the car and control
Mhm.
your entertainment. That's actually something completely different. What they're doing
Oh, is
now,
that so?
yeah, that's just like a extension of your phone. What they're doing now is they've made a complete operating system for the car and stuck it onto the car as open source for these auto manufacturers. And the Polestar was the first I've seen it in action. But I was like, oh my gosh, are you serious? Like people aren't talking about it, and that's why no one is really like looking at Google as something. But I encourage actually like anyone to look at these videos of the Polestar UI. But you're going
Mhm.
through it, and it's like flashbacks of the first Model S in 2012, where it's like
Hmm.
people were just amazed at everything you can do just on the screen and everything, navigation, everything, and it's built in. It's the operating system of the car. And I was like, wow, it's like no one is talking about this, that Google is moving into this. And I don't think anyone else is doing what Google is doing with the car at the level of free open source would give the whole operating system. All they need is an extra piece to that, which is, the autonomous driving software, package. And so it's not that big of a leap for Google in a sense to to decide to take that extra step and compete with. And part of me thinks that
I
maybe
would
they are doing it because
question
to
whether
compete.
it's central to. I mean, the rise of smartphones was I don't actually think of this as a very zero sum, like Google, it was existential to Google. I mean, I'm sure there were people at Google who felt that way. The people that I talked to who worked on Android, like back before it was actually a thing that they shipped out, they saw it as as smartphones as this big opportunity to expand their mission, to basically provide these information access tools to a much bigger audience. I mean, they definitely had this perception that, yeah, this is going to be a really big platform in the future. It's going to be the way that people in India, it's people in third world countries get access when there's cheap, ubiquitous smartphones and quality cellular. They were looking down the road and they saw this and they thought, this is a way for us to bring this service to more people. It's a way to get bigger. And it was super central to their mission, because essentially this massive expansion of the number of terminals that people can use to access Google, to get access to their services, like, is a really big thing. I don't know that I would see like Google, like the car would be a similar thing to them, a similar expansion, because people have smartphones in cars right now. Like if you needed to, if you were riding around in a Robotaxi and you needed to use a screen in the Robotaxi, and that was an interface that Google provided, that would be one thing. But I think most people are going to get in a Robotaxi and they're going to get out their smartphone and they're going to play with it, right? So if Google's got the smartphone, then they have that avenue. That's not to say that there's no merit for them, but I feel like that looking at the sort of intensity with which they went after the smartphone market might not be representative of the incentives that they have in the vehicle market. I can see it being an interesting market for them, certainly, and I wouldn't be surprised to see a scenario like what you're talking about unfold. But when I think about the number two, number three competitor coming to this space, who has a really strong vested interest and who has deep pockets and who is tech focused and who kind of recognizes the opportunity and the threat, if you will, for what it is, I see Uber, I see Lyft, I see the Chinese rideshare companies, and other countries are going to have a different sort of perspective on having an American company come in and do this kind of stuff, like maybe especially China, right? But the opportunities in India or Indonesia are really different than the opportunities are in the United States for all these players. And the local players that are really tuned into what's going on there, like it, I would be surprised if they didn't look at these developments and see an opportunity that they want to get in front of before they wait for this big foreign company to come into their market and take it away from them. Like I definitely think that's going to happen. And that scenario is a big part of why I feel like looking at Tesla as conquering the worldwide transportation network is a little bit of a step too far, because I can see so many scenarios in which they are super successful in some of these big Western markets and yet don't manage to get a foothold in other markets where the dynamics are a lot different. Right. And
That's
where
true.
the local competition has a very different set of incentives and cost structure and whatnot than the competition in the United States does.
That's true. I mean, on the flip side, though, like if Tesla's autonomous driving software gets so good, it with the whole fleet advantage, where it is significantly just like leaps and bounds better than anything else out there, then that advantage would actually be realized or be more evident in these more, let's say, undeveloped or third world countries where, let's say, the road conditions and hazards are just really, crazy. Like the best
Mm-hmm.
system would actually show itself more clearly, in those situations. So in that
Mm-hmm.
sense, Tesla could actually have an advantage as well, compared to anyone else out there.
Yeah, it's possible. I mean, I really do believe the barrier to developing a self-driving system is going to keep coming down and down and down, and that 10 years we're going to be in a very different world than we are today in terms of the amount of effort that it takes. Uh, if Tesla's only putting their systems on their cars, I don't know. It's I mean, they've got a $20,000. Maybe they'll have a $10,000 car that they'll sell, into super cost sensitive third world markets at some point too. And they could having a platform that you can put this thing on is also a super important component. I mean, if if Tesla's vehicles cost half as much as General Motors vehicles, and General Motors gets Google or Comma AI or somebody to build a self-driving system for them, and to put it on the thing. But we're in a commoditized world where the incremental value of the software in terms of the cost that you can charge is not that great. the Tesla still win because, in that world, the amortized cost of the equipment dominates the cost of providing service, right? And or the efficiency of your battery, because ends up being a big component. So there are these other variables that I think that are probably also really important, which could end up giving Tesla an advantage, right? If they get far enough ahead on their ability to manufacture these cars, then maybe they outcompete, local manufacturers in, I don't know, Mexico or, wherever. And that could end up being the thing that ends up making the difference, because I do believe that the relative advantage of the quality of the there's a point that you get to in terms of how good the safety record of your full self-driving is, where it's hard to charge more for it. It's hard to justify the premium. I mean, how many people know how good the airbag sensor is in their car? Getting back to that example, right? There's a level of good enough that people are satisfied with, and then they stop asking that question anymore, and then it's all about price beyond that point. So can Tesla succeed in the third world? Maybe. Like, I can imagine scenarios where it does, but I wouldn't put that on my spreadsheet right now for Tesla's future returns, because whereas I would definitely put the autopilot on my spreadsheet right now. Like, I look at it, and to me, that's the bet. In fact, I made my big financial bet on Tesla like a few years back, and between now and then, it's done super well, like on the back of the Model 3 and all of this engineering stuff. But I was super disappointed a couple of months ago that the thing that I bet on, which was like, that deep learning was going to be the thing, that really, I don't feel that that's caught the public perception. Like, I don't feel like that Wall Street, even, if ARK, who's so crazy bullish, like, has this, it's a long shot goal for them, and you look at all their assumptions going into the model, they're mostly pretty conservative, right? I'm like, Wall Street really hasn't got it. So, like, I felt compelled to, like, make another big investment a couple of weeks ago, because I was like, I'm going to win this bet. Damn it.
Yeah. No, seriously. Like, I think, yeah. When I think of Tesla, it's like, the first big bet was on electric vehicles, and ramping the Model 3, going into Model Y. They've proven like their first type of big bet successful. But I think this next big bet is this whole autonomous driving field and the whole robotaxi field. And over the next decade, I think this is going to be like an immensely exciting and very just interesting field to watch, because as you're talking, like, a lot of people first just don't get it, and second, they're not really like thinking this is going to happen. Like, you're just like thinking, oh, it's some geeks tech,
we're in the trough of despair on the
yeah
in the self-driving vehicle stuff, the Gartner hype cycle
exactly,
kind of thing. Like, people's expectations are really low compared to the potential for this tech right now. So it's there's another way you can tell this story, which is kind of interesting. Like, imagine that your mission is to accelerate the world's, move into sustainable transportation or whatever the deal is. And this is like a few years back. Yeah. And you're a very far-sighted, tech-oriented, entity. And you look at all this stuff and you say, you know what? Electric robotaxis driving everybody around. That's how we're going to get people out of cars as fast as possible. We're going to make super cheap. We're going to make, robotaxis. They're going to be great. They're going to be inexpensive. They're going to be super safe. Everybody's going to want to use them. And that'll get, all of these, legacy fossil fuel cars. People will just stop driving them. Like, the value will go to zero, and we'll just get them off the road, like, in one fell swoop, right? Because, man, one robotaxi is worth 10 times as much. And we're totally production limited. Like, no matter how you draw the graph, like, it takes so long to build factories and get up to scale that even if we're making great cars, we can't do this. Now, how do we really get up to scale really, really fast on robotaxis? Well, we don't have the software ready right now, but we got to start ramping our manufacturing capability. I guess we're just going to have to sell cars to private individuals until we can get the robotaxis up, right? I was like, so let's start working on the robotaxi software. Let's make a really good private car. And let's just have this idea that, we're going to transition into, like, it's going to be robotaxis and that kind of, like, you can tell that story about Tesla, or a company like Tesla, sort of thinking, it's the robotaxis, the autonomy, that's the end game. That's where we win. But we can't start with it because the tech for the taxi is not ready. And to leverage the taxi, we have to have this huge manufacturing base. We got to be making 20 million cars a year, right? And if we got to start building factories now, and we got to sell the product out of those factories until the robotaxi thing makes sense, and that'll be 5 or 10 years or whatnot, right? Like you could look at that story and you would still end up with exactly what Tesla's done, even if you had, even if like private vehicles really weren't part of what you saw as the solution anyway. Private vehicles are your way to leverage your manufacturing capacity to where you can get to the point where you can build enough robotaxis to really move the dial. Because seriously, if you're making 20 million if you're making 20 million cars and they're getting used as robotaxis, that's 100,000 miles times 20 million vehicles. So it's like it's a huge number of miles. It's way more miles than if those are private vehicles that you're selling. And if you want to, if you see the declining S curve of fossil fuel vehicle usage, you want to bend that curve and pull it back in time. Robotaxis they're so much more effective than private vehicles at doing that if you knew it was possible and if you saw a way to doing it, that would be
Sure.
the thing that you would see as what you must do.
Yeah, I agree. I think in some ways, like I think private vehicles, like I'm actually a big believer that private vehicles stick around for, quite a long time.
Yeah, I do too.
But they become more like a luxury item in a sense, they do cost a
Yeah.
lot, but you do it because you have some preferences on your vehicle. You do it because you want to keep your kids' car seats in the vehicle. You want to do it because you want to keep your, trunk stuffed with different stuff, your golf clubs or something,
I have a place in San Francisco and I have a place in Los Angeles. And let me tell you, the use cases for vehicles in those two cities are so different. It's
Exactly.
ridiculous. Like what it takes to sell a person in San Francisco, like in San Francisco, like I don't even drive my car. I don't like to drive my car into the city. It stays someplace else and it's all Uber all the time. If I even have to take a we ride the bus and we walk every place when we're in San Francisco because that's what makes sense, right? And there are huge urban populations in the world that are going to go that way. And yet, my dad who lives in rural Iowa,
Mhm.
he's going to have a car.
Exactly. You're not going to take away his car. Yeah.
It's just even when he can use Uber. He's used it before. He thinks it's a great service and that kind of stuff. It's just as a trade-off of convenience and all that kind of stuff. He has to
Yeah.
wait for it to get to his house, right? Like he only wants to go down the street to the grocery store, right? He doesn't want to wait 15 minutes so that he can take a 5-minute ride and then wait another 15 minutes so he can take a 5-minute ride home, right? He'd just rather drive his, 10-year-old Chevy Tahoe, it's cheap enough. It solves his problems.
Yeah, exactly. All right, James, I'm gonna go ahead and wrap things up just because
Yeah,
we've gone so
it's
long
just
and
us at this point.
and,
I think.
and we need probably to eat some lunch or something. I'm starving too. But yeah, I want to thank
Yeah,
you for just being so generous with your time and with your
you're
thoughts and
welcome.
knowledge.
It was a fun conversation.
Yeah,
We should do it again.
no, seriously, like I just have a blast talking with you because a lot of this stuff, like, it's just, I have a hard time finding people to really like geek out on some of these like issues or
Yeah,
questions that most people
I
don't think
know
about,
just how you feel.
Yeah, yeah. So yeah, so when I talk with you, I'm like, hey, someone's actually thinking about this stuff. But yeah, I
Mm.
want to do it again. The thing I want to talk with you again is what I think is going to be really, really helpful to people is the significance of ImageNet 2012 and kind of what that means in the bigger picture of neural nets, autonomous driving, Tesla's history. I think like that is so essential to kind of understanding context, of where we've been. And so, I mean, that's something I want to talk with you and hear
Should
your
talk
thoughts.
about, there's a lot of interesting data on how fast, everybody knows about Moore's law, and there's all these different formulations you can come up with, and it's got all this history. And there are all these industries that basically assume it's true. And they just like, their 3-year, 5-year plan is based on Moore's law happening or whatnot. But the thing is, you look at the pace of development in deep learning neural networks, it is astounding. It is like so far beyond Moore's law. It's just ridiculous. But most people in the industry, they're still in the phase of like, oh, this can't keep going, right? It's like, Elon with pretty soon we have to convert Jupiter into batteries if we stay on this curve or whatever the deal is. That's what deep learning is right now. It's like we're going to have to convert Jupiter into a computer if it's going to keep going in this direction. It leads to some very interesting sort of scenarios for like what the world looks like in 5 or 10 years if you believe this is going to continue, right? And an interesting thing about it is that most experts in the field at most points, and like you can look back at what people were saying, 3 years ago or 2 years ago or 4 years ago about this kind of stuff, and people didn't believe it was going to be continue. Like with a few exceptions, the experts have mostly been wrong, right? And it's a lot, when Moore's law started, everybody was like, Moore is smoking something, right? There's no way this can continue. And that was like 50 years ago, right?
Mhm.
So
Yeah,
it's very few people are familiar with the data underlying, the data that demonstrates that this technology has legs, and it's on a completely different level in terms of exponential growth to almost any other, economic phenomena that has ever
yeah,
hit the world.
exactly. Like I think people like I was telling people like back like 2014-ish, like about ImageNet, 2012 results. I'm like, this is you don't understand what's going on. Like this is the beginning of a new era. This is like people are, and still we're in the
Yeah.
year 2020,
And
and
it's not a one-shot thing either.
exactly, yeah.
The AlphaFold, the protein folding results that they got. I mean, you can look at all these fields where, this team of guys with a deep learning network, they come in to this relatively mature tech field that's got all these different approaches that people are working on. It's like, boom, done. It's like, let's go to destroy a different field and write another paper, next year. But the protein folding, like that's a huge thing. It's been going on forever, right? I don't know if back when the PS3 first came out, the default screensaver you could get to go with it was this folding at home thing, right? Because people have known for a long time that the protein folding problem is a really big problem for being able to make progress in all these medical and, biology fields and whatnot. And yet the progress hasn't been that fast, and it's still a big deal. So when you have some guys from DeepMind show up with a network that they knocked together over the last 6 months, and they just totally destroy all of these teams that have been working on this problem for 20 years. Like, and this was just our first try. We just knocked this together to show you guys what's possible, right? It's the same technique. Or, you can go back to AlphaGo. There's a tremendous documentary on that thing. And that wasn't the end of it. Actually, the most impressive things about AlphaGo, they happened after the events that at the end of the AlphaGo, when Alpha Zero and Mu Zero, where they were both follow-ons on it, are tremendously more impressive than AlphaGo. AlphaGo is a really impressive effort, right? But you look at the two follow-on efforts for those, and they really underscore this technique is so powerful. We've barely scratched the surface, and it is so general. It's going to apply to everything.
Yeah, I think we're like still in the first inning, of
Yeah,
machine
if
learning.
that
Like,
even.
yeah, it's like
So the
people,
pitcher's still warming up
yeah,
on the
yeah,
plate.
yeah. I mean, the significance is just mind-boggling. That's why I have such
Yeah.
interest in it, because it is transformative in so many different ways. I mean, beyond people's expectations. Anyways, thanks again, James, for the time, and yeah,
It
we'll
was a
talk soon.
pleasure.
All right, take care. All right,
Take
bye.
care.